Okay. So yeah, let's start. I hope everyone is able to hear me. Everyone is able to hear me? Good. Okay. So yeah, there is a delay. So I would ask everyone to kind of support all the speakers. I mean, you should not sleep. You should encourage everyone because there is a delay of a couple of seconds. No? Okay. I don't know why this is not working. I can try this one. Yeah. So let's start with the first one. Fortify Kubernetes, securing multi-tenant clusters with Kyverno and Falco. So we'll be discussing three tools today and see how it works in conjunction. So which is vCluster for creating the virtual Kubernetes clusters, then Kyverno for the policies, and Falco for the runtime security. Um, how many of you are well aware about Kubernetes? Know what Kubernetes is? Okay, just to set the context, so Kubernetes is orchestrated to contain. So let's say you deploy your code, you're opening Instagram, there are a lot of applications over there, or you're opening Twitter. So all these, like when you go to home, when you go to create tweet, when you go to all these small things, they are called microservices. So they are a specific set of applications. So you code, the container is like Docker, and you then deploy it so that it can run, so that you actually play with the technology. The micro, so you have a bunch of servers. On the servers, you install Kubernetes as an orchestrator, and then you deploy application on that. So that's your primer to Kubernetes. Um, and I currently work as principal developer advocate at Loft Labs. I'm founder of Cube Simplify, which is a community to simplify cloud native. It has a YouTube channel and all that stuff. You can follow all the stuff over there. And yes, you can learn Kubernetes too. And also, very safe is open source tool for CV based. And then, yeah, all the other things. And at the Saiyam Pathak is where I'm available on all the social platforms. Okay, so let's try to understand the concepts. Some of you are very new to Kubernetes also. We'll try to keep it as simple as possible, but somewhere it might not be possible. So this particular thing, this is an AI generated image. I hope you know by now. So the thing is, what you can do there are pros and cons to both of them. So one of the things is that buying a complete house is expensive, and you manage everything, like all the things, the gardens, the play area. If you are having all the stuff you have to manage, it's pretty expensive to buy an apartment too. But yeah, we'll not go there. The other thing that you can do is buy an apartment. So in the apartment also. So it's not that if you are living in an apartment, then you're not the owner of the flat where you're living. You're still the owner. You can still decorate your own. Box that you can use, but you're not maintaining that. What companies are doing earlier, 15, 16, 17, main challenge was these clusters difficult. All the cloud cluster provided a name, select the number of cluster to play around and work. It's a production level Kubernetes cluster that you get. So the challenge is not more about the Kubernetes adoption, but the challenge is now that there are too many Kubernetes clusters, because in the organization, everyone stand up and say, I need a Kubernetes cluster. Now, this leads to a problem of cluster sprawl. What that means is it leads to a problem of too many Kubernetes clusters within an organization. So as a team, as a user, different organization for different applications, there are too many Kubernetes clusters out there. And these Kubernetes clusters, so when you create a Kubernetes cluster, you do not like directly use it without installing some of the other toppings on it. So you install Argo CD if you are doing GitOps or Flux or Fleet or whatever is of your choice. You install Cert Manager or Ingress Controller. You install Prometheus. You install Vault. You install so many things on, and that effort has to be replicated across all the clusters, because anything in that. So it's just a bare bone Kubernetes cluster. So what it does is it increases the cost, it increases the maintenance of that. So there are thousands of clusters. So two types of cost, which is the control plane cost and the platform stack cost. These two. Now, if you see one of the reports by Gartner, the cloud spend is on the rise, and it has increased by 20% since 2023, which is actually pretty big number. And 70% of the organization out there. This is where a concept of multi-tenancy comes in. So what do we mean and what do we want to achieve? We obviously want to reduce the number of Kubernetes clusters. That is one point, because there are too many Kubernetes clusters. We want a way. Is there a way that admin, they are not the, we still want strong isolation to sort of, that has to be done over there. One is the workload isolation, that team A, team B, both of their workload should be isolated, should not be visible to each other. Pretty simple standard. Tenant autonomy, it'll come to a platform engineer or a DevOps engineer. So I just want the platform and the stuff to be self sufficient to handle all the needs and automate most of the things without writing a lot of custom scripts. Fair use of resources. I do not want team A to consume everything from the cluster and team B left with nothing. So how do we achieve that? So there is a concept of a namespace within Kubernetes. So in Kubernetes, you can create namespace. You use kubectl, which is a tool to interact with Kubernetes. So kubectl create namespace K8SUG. It will create a logical entity inside Singapore, and like this, it will be having multiple namespaces. On namespaces, you can do a lot of things. On namespaces, you can define something called network policies. So we talked about the workload isolation. So there is something that you can create within the namespace called network policies that lets you restrict the traffic going to and from one namespace to another. So you can define that, but here, yeah, it will be a bit tricky, because to interact or your particular tenant, which is tied to a namespace till this point, to be able to communicate with the API server. So you need two for that CIDR range. You need the port 53. You need some of the egress to be going out, except for all the other, like it should not, they should not be able to communicate with each other. So yeah, it's a bit tricky to write it, but you can write that. Most of the Kubernetes objects, when it comes to something called resource quota. So this comes as the fair use of resources, where you can define how many pods can be created in this particular namespace, how many services can be created in this particular namespace. So So this means, can we do namespaces per team? Can we have a concept where we have 5 teams and we create 5 spaces, we give spaces to each of the team. Naming conflict, many actions are namespace scoped. So we are saying namespace is enough, but are they enough? The thing is, there are a lot of things, and all of the things that I mentioned for the shared platform stack, for example, Argo CD, these are the custom resources that are deployed on the clusters. And custom resources are cluster-wide resources, persistent volumes. They all are cluster-wide resources. How do you cater to that? For example, team A says, I want Argo CD. Team B says, I want Argo CD of a different version. Cluster upgrades. Team A say, I want a Kubernetes cluster of 1.31. Team B says, I want a Kubernetes cluster of 1.32. Again, the concept of namespaces fails over here. So for all the cluster-wide resources, and also one config, how do you define the Kubernetes configuration? In the end, you have to give them some particular file to access. So you keep creating those RBAC rules, you keep creating the complex Kubernetes configuration files, and then hand it over to the users. And it will again be having the public endpoint of a single cluster. So you are giving the access to the host cluster, not restricted access, but still, if they get to that access, it will be difficult. So in order to solve this, there is a concept of virtual clusters. Think of it like you are going to Amazon creating an EC2 instance. You think that you are the owner of that EC2 instance, but it is internally running on a bare metal out there. You don't get access to the bare metal, you get access to the virtualized layer, and you get access to EC2 instance. You log in, you do whatever you want to do over there. Similar to that, we want to virtualize the Kubernetes layer. And here, the virtual cluster that is created is handed over to a team. They think that it is the actual Kubernetes cluster, which is Kubernetes CNCF certified distribution. They are able to create custom resources. They are able to create whatever they want and deploy whatever they want onto that particular virtual cluster. And they do not have access to any other Kubernetes cluster. So and they can use the shared platform stack. So now come back to the same analogy of house and the apartment that we just saw. So you can see that this particular virtual cluster is having the apartment, and these are the shared resources of the elevators, the park, the playground, all that stuff is being reused by all the tenants over there. And here, obviously, it's the multi-tenancy is harder here, but it is also very costly and the resources are wasted because you have two Argo CD instances that you have created and carried, two cert manager and all that stuff. So this is where vCluster comes in. vCluster is an open source tool to create these virtual Kubernetes clusters. So instead of saying cluster per tenant, we propose a model called control plane per tenant. Every virtual cluster gets its own control plane. What that means is there is a controller manager API server of that particular virtual cluster that gets spinned up as a stateful set on the host Kubernetes cluster. So all the requests that team A will do to their virtual cluster will only go to the API server of that, or the host cluster API server. So this is where it sits between vCluster. This is a separate cluster, obviously super strong and all that stuff. And then a bit isolation is pretty weak and restricted access. So yeah, Kubernetes in Kubernetes can deploy as fast as containers because it's just spinning up the pod on the host cluster. Control and costs are saved. You have syncing of the resources, so you can define in your vCluster configuration what all resources you want to sync to and from the hoster. Service improved in developer experience. How it looks like that should appear here in 1 second. Yes, host cluster, that's the virtual cluster created. There is a component in the virtual cluster called a syncer component. Now, this particular component is copying all the stuff from the virtual cluster to the host cluster and host cluster to the virtual cluster. For example, if you create a pod, the virtual cluster API server creates that particular pod. but it doesn't create it. So the syncer will copy that pod onto the etcd of the host cluster, and then the regular scheduling mechanism of the host cluster will kick in, just like they have to create any other pod. All right, moving on to Falco. So now we have created the virtual cluster, but what we want is we want the isolation. So Falco is a Kubernetes runtime security, or for Kubernetes runtime security. It parses the system level calls, and then it filters it against, it checks it against a lot of rules which are predefined, and then it gives the alerts on the basis of that. So this is how it works. So application goes to the Kubernetes, goes to operating system, all the calls goes to the kernel, and using the eBPF drivers, the Falco is able to get those system calls, parse it in the engine against the configuration, which are the set of predefined rules, enriches the data basis of the predefined set of rules, and also there are a lot of plugins that you can use to enrich the data, and then you can use the output to send it to Slack or serverless or Loki, wherever you want to send those alerts. This is how a sample alert would look like. So we'll obviously go through that. Another one is Kyverno. So Kyverno is also a CNCF project, and it is used to it's a Kubernetes native project for creating policies. So just say you want to implement certain policies like do not create node more services, do not pull from XYZ repository, and all these. So you can simply create those YAML manifest Kubernetes policies in a cloud native way using Kyverno. That's the main power of this, is that it is YAML based, it is super simple, and it is the cloud native way of doing things. That's how it works. Like whenever there's an API request that comes, it goes to it does the regular authentication authorization. After authorization, there is a step of admission. Now here in the admission, it will go through the admission controller of Kyverno, and here it will check the webhook controller, cert renewal will do the certs for the webhook, and the engine will make sure that everything is running, and then it will store the reports that whether the particular policies that you have applied on the cluster, whether it's cluster wide, namespace wide, and all that stuff, and then it will validate or mutate. Mutating means adding certain or removing certain information, and validating means whether this particular schema is valid to be applied onto the Kubernetes cluster. So it's just happened before it gets applied. So let's say you want to run a particular pod. Now, yes, you are authorized, yeah, you are the authentic user, you are authorized to perform this action, but according to our policy, you should not be creating this type of pod. That's what Kyverno means over here. Cool. Enough of the talking. Now let's move to nothing there. Okay, that was actually a blank slide. So let's move to what we'll be doing in the demo. So in the demo, what we'll be doing is we'll be having a Kubernetes host cluster. We'll be installing Falco, and Falco will be installed on the host cluster. Same, Kyverno will be installed on the host cluster. We'll be reusing Kyverno's policies and the Falco runtime, and we'll be creating a virtual cluster, and we'll be creating certain workloads over there, and see if we can use the shared platform stack. We can secure our Kubernetes cluster, the virtual Kubernetes clusters that will be created, so that it gives you a defined view in an organization that a set of policies on the virtual clusters that has to be created, and these are my Falco rules that will be it, so that it adheres to that as well. Okay, so now let's move on to the demo. Now demo will be a bit tricky because there will be a lot of stuff that I'm writing, and then there will be a delay here. So let's see how it goes. So this is the regular Kubernetes playground. Anything yet on this particular cluster? So kubectl get pods. You can see that. So just the regular plain Kubernetes cluster. So this will act as our host Kubernetes cluster. By the way, these are just labs. You can actually they're playground kind of thing. So you can actually go here, create a playground, and try it out yourself. So what we'll first do is we'll install the vCluster CLI. Okay, there's not that much delay in the demo, which is good. Now we'll install Falco. the next thing that we do is so this particular playground doesn't comes with uh, storage class and persistent volume, because our V cluster will need to is we'll install ranchers local path provisioner. It's basically very simple storage class that it stuff like that. So it's pretty simple over there. You should start it. Yeah, there you go. And the next thing is we'll patch the storage class to make it as a default storage class. So it's patched. Now if I do kubectl get sc, I should see a storage class. Next thing is the creation of virtual cluster. So we'll be able to create the namespace and the command is appearing on the screen in a moment. Yeah, so this is the one that is creating that, but so it's waiting, creating the name, doing the initial checks, pulling down the API server images, and all those things, and then it'll start. In the meanwhile, I'll show you what we'll try to do next. And yeah, I hope by now we should have the Falco pods running. So kubectl get pods. And as you can see, the Falco runs as a daemon set on all the nodes. So it's running on the control plane node and node 1 and node 2, which is a 3-node Kubernetes cluster over here that we have. And all the pods are up and running. So vCluster is starting the background proxy. We'll open another dev machine. And now if you can see anything else. And I'm in the Kubernetes cluster. Now I am in the virtual Kubernetes cluster. So it automatically creates a new kube config file, switch me over there. But at the end, when you will be doing it is, you will be getting that kube config file, sharing it with your team, as part of your platforms or whatever mechanism you are having. And then once they try to export that kube config variable or file, whatever that is, they do kube get pods icon and they'll only see the code DNS pods. That's it. Not they are able to see anything from the host cluster yet. But we know we have host cluster, we have Falco, we have all that resources deployed on the host cluster. Now what we are trying to do over here is we try to create a SSH secure code box. Now this is what we are doing on the virtual. So we are contain creating should be running. Yeah, now it's running. So kubectl exec, and let's go inside the pod. We can set the password. It's just a regular SSH server. I mean, dummy. So if we try to open a shadow, basically a sensitive file. The idea here is that inside the virtual cluster, I have a workload and I'm trying So I would want that to be appearing inside my Falco logs for this particular cluster. That's the idea. If it doesn't work, we'll see. But ideally, it should work. If it doesn't work, I'll say, no, it's lagging here. Oh, yeah, definitely, I can do that. Yes, yes. So, and we'll see which node it is there. So kubectl, oh, sorry, this is again. kubectl get pods -o wide. So it is running on node 1, pods -n Falco. Wide node 0, kubectl logs n Falco. Let's grep shadow, hopefully. Yeah, you can see just did the cat of /etc/shadow. So there was a sensitive file that was opened by a non-trusted program. So basically, I did that on the virtual cluster. Let's do it on the host cluster is Kyverno because we want some policies to be respected cluster wide. Whether you have 10 virtual clusters, you have one virtual cluster, I want. So this is the policy. And we obviously have to install Kyverno because that was a plain. So these are all commands are from the documentation. So you can just go to any like Kyverno documentation and get these. What this particular policy means is that I want a service type of node port inside my host policy. So that's a cluster policy. So let's apply that on the host cluster. And by the way, kubectl config get context. So you can see that I am in the right Kubernetes, like I am on the host cluster. Kubectl apply -f. So the policy is created. We'll try to run this particular command. And it failed. Okay. So I just applied that particular policy that I was showing you. And then I created the service type node port. I tried to create a service type node port and it failed, which is true. Now this is on the host cluster. On the host cluster, obviously everything is working, but we want to see if this works on the virtual cluster as well. So I go copy the command, I go to my dev machine, I'll check kubectl config get context, and you can see you will be seeing that my context is the virtual cluster context, so that you know that I'm not cheating and I'm again doing it on the host cluster. Sometimes it takes a bit more time. Yeah, so as you can see, I'm in the virtual cluster context. So it's a V cluster, and I'm trying to now create a virtual service. I pressed enter over here, but here you will see, I know it worked. So there's no suspense over there. So the node port service, again, we are not able to create. So the virtual cluster also is respecting the cluster wide policy that we created. So there are a few things that we learned today. One is definitely how and why multi-tenancy is required because of the rising cost and the cluster sprawl problem, and you want to create multiple Kubernetes cluster, use the resources efficiently in your Kubernetes cluster and create, and also want that level of isolation where you have the control plane. And then we saw how there can be a shared platform stack that can be on the host cluster, and you can reuse those as part of your virtual clusters as well. So this creates a kind of complete policy poster of your Kubernetes cluster with runtime security, Falco. You can have another set of tools as well.
Guys, those who are outside, we are requesting you to please come inside so we can start.
So that it scales up and down, and you are not waiting for it to happen, or you're not monitoring it by yourself. So this is some of the architecture of AKS which we see. Like you see that the workload and the infrastructures have been divided, and it has microservices where your application is divided into some part of the microservices, and the governance part also can be taken care as a separate microservice, and your workload can be deployed on this, and you'll be just taking care of your day 2 operations, nothing on the day 1 or day 0 operation. Microsoft takes care everything of you, for you on that side. So So these are some of the benefits of using AKS. So as I told you, it's cost effective as Azure manages your control plane, and you're not been having a lot of issues on the Kubernetes side, which will not be taken care. And you know the API server, which is one of the control plane component, which keeps communicating with all of your pods and nodes and has a lot of features which you are not aware, but still you can put your application into AKS and make sure that everything is handled at the back of your hand. So even though you don't know what your control plane component is doing, deploying an application into AKS is just with few clicks, which I'll be showing it in a demo. And it's always high available and scalable. So since this is always on AKS, and there are some teams which are taking care of the scalability, and the control plane components have been taken care by Azure. So you'll be having free of mind to think about the application features rather than thinking like, when my application is down, what should be done? So that part will be taken care by the Azure side. And as you all know, there is a lot of DevOps tools from the Azure side, like there is Azure DevOps, and there are other security tools. So all of this can be easily integrated into the application side. So which makes us makes the application more secure and easily available for the users. So this also supports the hybrid and cloud strategies. Like we see that there are Azure has a way that you can connect even the other clouds, be it GCP or AWS. You can easily connect it into the existing application and make sure that some of the things, if you feel like it's going with the other clouds, it is easily utilized there. So you can make sure that all of the other clouds have life changes. Yeah. So it supports all of the hybrid, and it also supports multi-cloud, where you can utilize the other clouds to be integrated into your cloud. So these are some of the advantages of having AKS. So the deploying applications on AKS, how can you deploy? Now we got to know what is Kubernetes. We understood why we need AKS. Now we understood like what are the components. Now what is the way you can deploy applications on AKS? First things we'll be doing is, we'll be having something called as a deployment in the form of a YAML file, which is like used to deploy applications. You'll be having some of the features in the deployment like replicas, and you'll also have some of the features like what are the strategies to be used when something is going wrong, whether you want to roll back, and all those that will be mentioned there. And we'll be also using some of the things called Helm charts. Helm charts is like, you know, Kubernetes is an orchestration tool. And when you have a lot of clusters and you want everything to be taken care, that's when Helm charts comes into picture. So what we'll be doing in the Helm charts is, it's a form of a package where you can install everything related to your application in the form of a package, even if there are thousands of Kubernetes clusters. So we can integrate this application with the CI/CD actions of the GitHub, and we'll make sure that whatever changes you're doing is being sent live across, and you're not waiting for some approvals for your changes to be approved and all. So the continuous integration and continuous deployment of your application becomes very easy now. And it is also very, and making sure that is working as expected is also very easy with just some of the clicks. And also to monitor and troubleshoot what is happening with your application. There are some live metrics which can be analyzed and make sure that everything is as you have set. And also there is something called as Azure Monitor, where you can check across and have some metrics and rules set across for seeing the utilization of the resources, or being notified when something goes wrong to your engineers who are in the backend. So as we know, we understood what are the users, right? So there are some of the use cases, like which are the best things which can be utilized with the AKS. One is like when you want to have microservices. As you all know, monolithic services have been gone and everything is being divided now into microservices, where each part of it will be having a small box type of service where it will be interconnected and will having conversations within each other. And AI/ML. And I think this is one of the best examples, which I'll show you across now. The hybrid cloud, as I already mentioned, that it can integrate easily when you have a lot of other components spread across the different various clouds. And the IoT workloads. When you want to deploy anything on the IoT, I think this is the best way to deploy it, since all of the resources required for deploying IoT, Internet of Things type of workloads is easily available inside the AKS. So now we understood the use cases. So what are the best practices? Now we have decided that we want to use AKS. What is the best practice, or what are the suggestions that you should take care when you're deploying something on the AKS? One thing is you need to use RBAC to make sure that the right people are given access and the right integration of the people has been happening. And you need to utilize the performance features which is available. So when you know that after your application can take a load of minimum 100 to 1000 users, and anything above that, there should be something taken care on the auto scaling side. Maybe that is the right time for you to set those metrics here. And the other thing is you need to be implementing your Azure monitor and make sure that you have some other tools to have some dashboard type of representation, be it Prometheus or Grafana, which shows across the various metrics in your, be it CPUs or what is happening on the pods, like what is happening on the deployment. There are some templates available in the Grafana, which you can integrate from the Azure monitor, and you can make sure that live metrics have been shown across in your dashboards. And it also gives you details onto how many clusters are there, what are the nodes, what are the pods, how many pods are healthy, or what is the health related issues happening regarding those applications. So you need to implement all of these features. Even though those are present, these are some of the key recommendations we give to make sure that whatever the features are there are rightly utilized for your application. The other thing is make sure that you're always using managed identities. And you should always have either system or user managed identities instead of having a role and making sure that everything is happening from the tool. This will enhance the security and also make sure that unauthorized people are not logging into your applications. So this is a small demo I'll be giving across today. I have already I have completed until this step 5 because of the time constraint, and I didn't want to do it here because deploying anything on the AKS will take nearly like 5 to 15 minutes. So when I want to create a AKS cluster and push my application into it, but I'll be just explaining the gist of what I've done. So I already have an application. I'll just show you across. So I'll be giving a demo on face blurring. So all of you know that there is a lot of security issues and a lot of rules and regulations coming up. And when you want to put up a photo or something inside your social media, there are a lot of regulations when there are unnecessary things or unnecessary people faces present. So you want to blur those faces. So I thought I'll give a demo on how you can utilize the script where the script is utilized to blur the faces in the photo. So what the script is actually doing is it's a Python script where whenever it sees a face, it is using the OpenAI where it is blurring the face on a photo and making sure that that is put across on your local system. So what I've done is this is the file which is present, and this is what it shows like to make a square of the face present and blur it. And what I've did is I've created a Docker file for this. And now the fun starts. I made sure that this is working locally first before creating a copy of it and pushing it into the Docker. So the first step, as I showed here in the PPT, so I set up the environment, I Dockerized the application, and make sure that it is working locally. And then I deployed it to the Azure Kubernetes service. So I have already deployed into the Azure Kubernetes service here. So I have AK's cluster which is running, and it has the image, the Dockerized application is pushed across like an image into the Azure Container Registry. Azure Container Registry is in the form of like I can say it's a form of a folder which will hold the images of all of your applications. What it does is, it takes across that image, and my Azure Kubernetes service, AKS, will deploy that image in the form of an application. So before creating an application, I will have to create something called as deployment in Kubernetes. So that's the reason this deployment file has been used, where it shows that this is the image in my Docker ACR, which is Azure Container Registry. So it will be pulling this image, and this is the container code it will be using across to make sure that is displayed. And I have already created a secret called ACR secret, like which is used for logging into the Azure Container Registry. So I have created a small deployment here where it has just 2 replicas. Normally we suggest you to use 3. So, but here I'll be just using 2 replicas for this. So this is a deployment file. The other one is, this is called as a service file. So the service is used to expose your deployment. So when you want something to be visible to the outside world from your Kubernetes, that's when you'll be using something called a service. So service is used for showing your app to the outside world. How do you do that? There are a couple of ways. There are 3 ways in which you can show your application to the outside world. One is cluster IP, when you want your app to be visible only inside your organization. That's when you use something called as type cluster IP. The other one would be node port, where you were seeing something from Saiyam, where he had put some of the node port numbers. Through that node port, your app will be visible. The other one which I've used here is load balancer, where, as the name suggests, it is balancing across the load between the 2 of the replicas which it's created, to make sure that both of them have equal number of requests coming in, so that the server is not overburdened. So that is what we have created here in the service.yaml file. And my service.yaml file and the deployment file are both linked through the selector, something called as match labels, where it is selecting the service which I've created is used for this deployment. So how are both of those linked? Through this match labels, and it is using the selector option here. So this is the label I've given for my deployment, and that is the same label I'll be giving here for my service, which is linking both of my service and my deployment. So these are just 4 files which I've created, as I've showed you. One is Docker file, one is my Python file to blur the image, and 1 deployment and 1 service, just a small one. So I already told you, I've created a Kubernetes cluster. So let me just get the nodes. Yeah, my nodes are ready. I've created 2 nodes. Let me just get my deployment and pods. So I created a cluster, AKS cluster with 2 nodes, and I created a deployment with 2 replicas, and which replicas means 2 pods, which are already in the running phase. This is the service I've created. So as you can see, there is an external IP which is put across. Let me zoom across. So as I told you, if someone wants to access my application, it's done through a service. So once the service called face blur service is created, now my app, face blur app, has been visible to everyone using the external IP 48.216.153. So that is the IP I'll be using across to access it. So I'll be sending a curl request where I'll be posting across the image which is present in my laptop and making sure that my face is being masked and it shows across the whole image except my face. So that's what I'll be doing. I'll be just showing across what is that image now. Yeah, this is my image. As you can see, my name has been present. So I was one of the WTM ambassador where we were given across for WDM Academy, where we had a lot of informative sessions there. So I was one of the member there. So as you can see, this is one of my LinkedIn posts where I posted it across with my face. And now I'll make sure that my face is not visible and it's been blurred. So as you can see, I'm sending a post request to my app, and I'm also giving the image location present with my laptop, and also I'm giving the output location where I need the blurred image to be present. Just start it off. So as you can see, it started off executing now, and this is happening from my Azure Kubernetes cluster now. As of now, it was happening on my laptop. So since I Dockerize the application and put it across into the Azure container registry where my AKS cluster pulled that image and created as you can see, this 48.216.153.206. This is the service IP which it is used. So it means that my service, face blur service, is this service is pulling this image and it is outputting the blurred image into my folder. So let me just go back and get the blurred image. As you can see, there's a new image being created here with the name blurred image. As you can see, it's blurring my face and making sure that the sensitive details are removed. So this is a small demo I wanted to show you guys today. And what is the use of this blurred images, right? Like there are a lot of use cases for this. When you go for some medical fields, you see that some of the patients' faces are blurred to make sure that the sensitive information is removed. And also when you see some of the times that if you'll be seeing in the movies or some of the videos where car number plates have been blurred. So there are a lot of use cases for this. So these are the places where you'll be utilizing face blur. So this is a small demo I wanted to give where it is so easy. Yes. Sorry? Yes. 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 It detects all of the faces, only faces. I tried it with anything else with other animals or something like that, but it doesn't detect it. It is a small app which is only detecting facial recognition. Yes. So this is how you can utilize even your small apps to make sure that is scaled across. And I just created so once I created something called AKS cluster, you can see so many things being created at the backside. So it created a network security group, it created some virtual machine scale set, and it also has a storage account, it has analytical workspace, and it has my AKS service, like Kubernetes service, which I showed across now, which is used to expose my app. And it also created some of the identities which I told you. It is required for security purpose. And also it has the load balancers. So which I created across for making sure that my service is not being burdened. All of this has been created with just one command, AKS cluster create. So that's how you can utilize the Azure Kubernetes service to make sure that your app scales across. This is a small demo app which I did. Most of you here would be having some of the startup ideas. Maybe it would be small at present, but you can try out the available services here and make sure that it gives you a sense of accomplishment when you see that all of the things you have learned has been present across, and it is all happening with just some few clicks. And even if you're struck across, there are a lot of documentations available for you to try it. So this is a small demo and what I wanted to talk about today. And I hope this inspires you all to try out some of the major app type related things we want to host on AKS. And you just saw it was such an easy thing where you want to have something called as deployment and a service to expose those. And you need to have some of your application in the form of a Python or any other language. And this is how you can utilize AKS and make sure that it is scaling your app and it is secure and it is available easily for everyone to utilize. And thank you.
We will some Kaustubha. So we're moving forward to the next talk, which is GitOps Dynamics. Navigate the era of DevOps, which is delivered by Megha Kadur, senior software engineer at Barracuda. Over to you.
Hi everyone, how are you feeling? Good? Okay, so my session will be simple and short, so it would be like, don't get bored. I won't make you bored also. And my session is all about GitOps dynamic navigating the new era of DevOps. That is what we're going to see today. Before that, I would like to give a short intro about myself. So my name is Megha Kadur and I'm working as a senior software engineer at Barracuda Networks, which is a cybersecurity company. And apart from my daily work as an engineer, I also like creating, tech videos on my YouTube channel. So the channel name is Tech with Megha. You can reach out to me there and connect with me. I also like writing, tutorials, and that's the way I also learn, and I get a chance to share it with people also. So you can reach out to me on LinkedIn also, and then on TopNet, where you can, I provide mentorship, as well as if anyone is want to explore their career in DevOps, you can connect with me. So that was a short intro about myself. We'll straight head into the session. Okay, so what we're going to do in the session is we'll understand what GitOps is, and then we'll understand its workflow, how it actually works, and then we'll do a demo at the end where we will be doing a complete CI/CD pipeline, and at the end we'll try to do any kind of deployment like blue, green, or canary kind of deployment. Okay, so it's basically understanding how GitOps works and how you can incorporate that in your project also. Okay, so before understanding what GitOps is, we just need to understand what DevOps is. And I know most of you know what DevOps is, right? So when we search about what DevOps is, that in the Google we get a definition like DevOps is something that is trying to bridge the gap between Dev and Ops team, right? So DevOps is at a certain level, it is helping us to automate our process, do our deployment, helping developers to deliver their feature, right? Now we're going to see is how GitOps is going to enhance this process. Okay, so what is GitOps? So the same way, when you try to search about GitOps in Google, you'll get a definition that GitOps is something that is trying to perform continuous delivery. And it works on one of the major principles where it tells as it works on Git as single source of truth. Now, what do you mean by Git as single source of truth? When we write feature, we store it in some code repository, like GitHub, GitLab, Bitbucket, anything. Same way, GitOps is telling you to store your infrastructure repository also, where you have all the YAML files that depicts or tells how your application should actually behave. That is what Git as single source of truth, the meaning is of. That we'll see in the upcoming slides. Okay, so these are the two main concepts. Sorry for the image, it's not coming up. But yeah, application repository and configuration repository. Now, what do you mean by configuration repository? If you want your application to behave in a certain way, you will write some YAML files, some Docker files, or you might write certain deployment service ingress. This is actually telling us that how your application will behave when you actually deploy them. So GitOps is telling us the way you store your code repository, also try to configure that in the Git repository. That is where you have your configurations YAML files. Okay, so GitOps works on basically 4 major principles. The first one is declarative. So the word itself is telling us to declare something. Now what you're going to declare? You're going to declare how your application will behave. And how you will declare it? The same way, the example that I gave, your Kubernetes YAML files, or if you're using some Terraform, those kind of YAML files will declare it. Second principle is telling us to version and immutable. So what it means, whatever is your desired state is present in your configuration repository. Now keeping it in your personal laptop won't work, right? You have to somehow you have to version it. That is where Git actually plays the role. So you will be storing it in your Git repository so that you would be having a history of it and you know what is happening. Okay, so the third and the fourth principle is telling us that pull automatically. Now, how GitOps concept works is you would be having an agent, or think about a GitOps agent that is sitting in your Kubernetes cluster. So what it will do whenever there is a new feature or whenever there is a new change coming up and you want to deploy it, that agent will automatically get to know, okay, this is something new and this is not actually equal to my desired state. So you can see here, actual state is equal to desired state. So what is your actual state and what is your desired state? Your desired state is what is defined in your YAML files. What is your actual state? That is actually available in your production, like live it is running. So the main task of GitOps is it will always 24/7 keep an eye that your actual state should always be equal to your desired state. So that's how the pull automatically will work. You have to configure it in your dashboard and it will automatically get to know there is something change happening. Let me pull that change and apply it into the environment. Fourth is continuously reconcile. Now, once it actually applies the changes, it won't stop there. It's like a continuous loop that is going on. It will apply and again it will monitor. It will apply and again it will monitor. It's like a continuous loop that is going on. That is what the fourth principle is telling us. Okay, so when we talk about deployment strategies, there are basically, you can say, two major strategies. One is your pull-based strategy and other one is your push-based strategy. So now here you can see that we have a CI/CD process being depicted here. So what happens in push-based repository is you will be having a developer who will be writing the code. And once the developer writes the code, he will push it into your code repository. That is what happening here. Then you will write some test cases or you will try to build your application using some build tools like Maven. And once you build that, you will generate some artifacts. It may be in any form, a Docker image, or you can say Helm charts, whatever it is. For the example, I'm taking a Docker image. As soon as it gets generated, how are you going to apply that new feature? So if you're using Kubernetes, you'll do kubectl apply. If you're using Terraform, you'll do Terraform valid, Terraform plan, and Terraform apply. If you're using Ansible, you will try to apply the Ansible playbook. That's how the command will be running. Now, what are the some issues, or you can say some kind of drawbacks that you see here is that you have to give read write access to each and every one. Imagine that in your team there are around 10 to 15 members, 10 to 15 developers who are working. Now if they want to apply some changes, each and every one should have a read write access, right? Then only they will actually apply the changes. That is one security concern. Second thing is your Kubernetes cluster will be exposed. So CI and CD should communicate with each other. Then only those changes will apply. So you have to expose your Kubernetes cluster details and your cluster login is embedded in CI system. So one thing what you see here, say that tomorrow your company is telling you, okay, that because of some cost issue, we need to migrate to another tool. Now what happens in this case is that when you try to migrate your CD, you have to do a reverse engineering, extra work to configure your CI also. Because your CI and CD is tightly coupled with each other. Any changes you make in CD will indirectly affect your CI. So it's like extra effort you're putting there. So how do we manage and try to solve these kinds of issues? That's where we try to make use of pull-based deployment strategy. Now what happens here, you can see CI, CD, both processes are there. CI is completely same. There is no change in that. The change comes when you actually do the CD process. So there will be a what you can say, an agent. So the orange color that you see is a tool that is called as Argo CD. Argo CD is a tool that actually you can say that depicts your GitOps domain, like the GitOps concept. That is how it is implemented. What I will be doing is, in my cluster, I will be having my agent setting. So as soon as I make changes in my configuration file, I know that repository. I know in which repository I have my configuration file. And I'll tell my Argo CD to keep a 24/7 eye on that repository. Any changes you find, pull that change. So you can also configure manual intervention also if you want to configure that. If it is something production environment, if you want someone to approve it, you can keep that approval also, that whenever you raise a PR, there should be an approval and then only changes should be merged. So when the changes, there is a new feature coming, the agent will get to know and it will say my actual state and my desired state is not matching. Let me pull that changes. It will automatically pull that change and it will apply in your Kubernetes cluster. So now what we see here is that if tomorrow someone is telling you that, okay, we'll migrate to some other tool, you just need to change the CD part, whichever tool you want to use, and your CI remains untouched because it doesn't have any dependency on it, right? So, and you don't even have to expose your cluster, what you can say, cluster details also, because your Argo CD is itself sitting within your cluster and it doesn't have to explicitly define things for it to work. Okay, these are some GitOps features. So what it says is, the first one which I talked about is single source of truth. If tomorrow something happens, for some reason, some disaster happens and some downtime is there, we know where to look. So there is no multiple copies of your application. Say for example, if there is a downtime and it's like Friday evening, you know, right? In Friday evening, we are very ready to go home and enjoy Saturday, Sunday. Imagine something happens on Friday evening. You being a DevOps engineer or who is working on DevOps concept, you have to sit, you have to fix it, unless and until, because your customers are dependent on that, right? So in such case, what happens? Instead of doing multiple changes and applying it, you know where to look. You know you have the issues and where to look to that particular file, and you can make those changes. Same way, application rollback becomes easy. So there is something called Argo rollouts, in which like you can make your environment up and running, and if something happens, you can easily roll back it. And CI/CD automation, the one diagram that we saw, CI/CD automation becomes easy, and finally deployment and configuration drifts. So if there is any kind of drifts happening, we know that, okay, there is no, we don't have to log in into the cluster and directly do the changes. You can come up and in your Git repository, you can make them, the changes. That's how some of the GitOps features are. Okay. So this is Argo rollout. Argo rollout, you can say it's not like you have to use it with Argo CD. Argo CD is a tool in which you'll make use of CI/CD. Argo rollouts is also having a separate dashboard. If you want to use it separately alone, this you can also use that. So we know that there are various deployment strategies, right? Like we have canary deployment, we have blue-green deployment, recreating. All these deployment strategies are there. Think that you have an environment. In that environment, you're serving 100% traffic to application V1. So V1 is your version 1 that is at present running. And V2 is a new feature that is developed by developers in your team that needs to be deployed. And we know that whenever we create something new, we know that certain risks are associated with it. We do not want to deploy it directly, right? I'm taking an example of Canary here. So what will happen is when we use Argo rollouts, we'll see that in demo, okay? So how it will work, first 100% traffic is serving here, then application V2. Then what happens is out of the 5 pods, 1 pod will go. That is depicting your second step. 80% on application 1, 20% on application V2, which is new one. Slowly it will shift to 40-60, and finally it is serving the latest version that is deployed. That's how a canary deployment will take place. Okay, this is just the same example that I talked about, right? So a developer is committing some invalid YAML files and we cannot keep a track of it. You know, if there is some high issue coming up and we have to fix it, like we will fix it because our customers are waiting. We'll fix it and everything is done, but there is no track. Tomorrow you come and try to see what are the changes, you won't have any documentation or any kind of track of it. That's why we say GitOps, which works on Git as single source of truth. How the architecture will look is, you can install Argo CD in one of your cluster and make it to look into other clusters and apply the changes also. You can configure it with UI CLI, and also you can send out some kind of notifications if you want it. That's how it will work. Okay, these are some of the tools that we see, Jenkins, Argo, and Flux. I think that Argo CD is most widely used. If you want, you can also like play around with Flux and Jenkins. Okay, I'm there on TopNet. You can reach out to me there if you want to have any kind of mentorship. We'll head into the demo now. It's visible? Shall I? Okay. Okay, this is just my Git Automate repository. What I'm doing is, so basically I'm using GitHub Actions for CI and Argo CD for doing my CD process. So this is just a simple CI pipeline. It's okay, right? Should I increase it? Control. Okay, what I'm doing here is, it's just checking out the code, a simple sample application I'm using. I'm with the help of my Docker file, I'm actually creating an image. And after creating an image, I'm pushing it to Docker Hub. I'm using Docker Hub as my, what you can say, repository to store my images. So right now you can see the latest version that is deployed is 41. This is how the Argo CD will look. And if you come here, so you can see release 41, which is our latest, at present, this is the latest code. Think that this is the latest code that is running. Okay, so coming to CI, what I am doing is creating a Docker image, containerizing it, and I'm actually pushing my image to my Docker Hub. Once that is done, just ignore this SBOM part. I'm actually doing a modification. So what I'm doing is, this Argo CD is constantly looking my configuration YAML file. That is my Git Automate repository, where I have my configuration repository. There I have my deployment YAML file. So you can see this. This is the CI YAML file. I have named it as CI YAML file. So any changes you make in your configuration file, Argo CD will get to you. So we'll try to do that. So just for the demo purpose, I'll commit a sample change. I'll refresh this. So once I do a change, my pipeline will start triggering. Let's wait for this pipeline to get completed. Meanwhile, I wanted to show you about the, I talked about Argo rollouts, right? So this is how the rollouts will look. This is the YAML file that you have to write. So in the line number 6, 7, 8, that's where you can define your strategy. If it is canary, define canary. If it is blue-green, you can define blue-green. So what I'm doing is, whenever there is a 20% traffic given to the latest version, I'm giving a pause. So instead of pause, you can also configure some details like only these checks are completed, then only move to the next percentage. It's up to us what we want to configure. Then 40, then 60, then 80. That's how the rollout will actually happen. So how now you can see in the CMD that you can see rollout demo. There is an image red, color red is actually serving right now. That we can see itself in the. Okay, so you can see demo red. This is the latest thing that is running. We'll try to update it. So now we'll change it to yellow or any other color if you want. That thing gets updated. Once we do that update, we can see that it is changing. The new canary is coming to yellow. But I have given a pause there. I have given a manual intervention that unless and until I approve it, It should not go to the 40 to 60 and finally to 100%. So what I'll do, I'll go back to my this. So you can see, first it was red, now it came to yellow. There is a pause. I'll approve it from my end. I'll say yes. As soon as I say yes, the other pod is coming up. Slowly, all the 5 pods will be shifted to the newer version. And if something happens, you can automatically reverse back to the older version that we have, right? So this is how Argo rollouts work. We'll get back to this. So it is successful. I think just ignore the above one. And I'll just refresh this. Refreshing. Okay. So now it is 42. If you go to the Docker Hub, you can, earlier it was 41. Let me refresh my Docker Hub because that's my, think of it as a new feature has been deployed, that is 42. So Argo CD has automatically pulled it, deploy the changes, and you have your latest application running in your pod. If you don't want it to automatically pull the changes also, you can configure there, keep a manual intervention that it will give you notification, new changes, approve it, and then it will deploy. So that's how Argo CD and Argo rollout will work. If you're extensively using what you can say Kubernetes cluster for your deployment, this would be one of the best way to try out and see if it is suitable for your project or not. And I'm working for Barracuda network. So if you want to, we have around 20 products where we provide security for application and your data, what you can say, your all kind of OneDrive, SharePoint. If you want to have a trial version, you can reach out to me. I can help you to configure that. That was a bit about myself and my session. Hope you liked it. Thank you.
Hello. So now probably we have some gifts to share. So for that, there will be a small quiz of 10 questions. I'll share the keyword. You guys can join and answer. So there will be 3 winners. So give me 2 minutes. I'm just joining on this one. And I'll share the keyword on the screen. Yeah, if someone is interested, please join this. And once everyone joins, I'll start the quiz.
So you'll be seeing some prompt telling like quiz will be started in 6 minutes, but we'll start before. So we started at that.
So we are waiting for you to join.
Yeah. Whoever wants to join, there is no coming back again.
Yeah.
Hello.
Everybody join.
So yeah.
Still some people are trying to join. Please do it ASAP. Sorry.
Yeah, we will start in 6 minutes. Like we will start this now. Just we are waiting for everyone.
Ask everybody to join.
Saiyam, personalized. The first two leaderboard people will get stacks. Moving to the next question. Good question. Last second question. Last question, guys. So I can see on the leaderboard, Saiyam and Rumer. Awesome. So have a round of applause for Saiyam and Rumer and other who have participated and played. So I would like to call Syed Imran. Where is it there in this room? Yeah. Yeah.
Thanks a lot.
Yeah, Rumer. Second person. Oh, that's
Thank you. Can you share that photos?
Yeah. So, guys, we are moving forward with the next talk. After that, we will go for lunch. And yeah, guys, we can see you are excited for this event, and most of the participants trying to join a bit late, but they couldn't because of the venue capacity. But we really appreciate your presence again. And again, those who couldn't make it this meetup, we would like to invite you in next, which is happening on 22nd March, most probably at Google. So yeah, guys, we can go ahead with the next talk. The third person from the leaderboard, Rayan. Yeah, is it? Yeah, just give us the your email to Kunal. We are also going to play another quiz at the end. In that quiz, we are also going to give the Code Cloud subscription for the 6 month and another 2 Kubernetes Bible book, and we have swags and stickers for you. So our next talk will be containerizing intelligence, building a scalable knowledge graph assistant, delivered by Siddhant Agarwal, developer relation lead, APAC, Neo4j. Over to you, Siddhant.
All right, cool. Is everyone in? Should we start? Yes? Yes. I'm talking to all the Kubernetes experts out here after the quiz. Or at least few. Yes. How many of you are Kubernetes experts? Cloud native experts? Big show of hands. Come on, it's okay. I'm not going to ask you another question. That's okay. I'm not an expert. So it's okay if anyone is an expert. No one? Who's an expert? Come on. Well, here's our Kubernetes meetup. You should be an expert, no? No, right. Just kidding. All right, so I'm gonna start quickly. I don't want to waste time. I know I'm the one who's starting between lunch. I'm not sure if we are going to do the next talk before lunch or not, but yes. That's a little bit about me. If you want to read more, you can just scan my QR code and then read more about me. I lead what I do professionally. I lead developer relations for Asia Pacific at Neo4j. That's my bread and butter. But I also do a lot of talks, workshops, sessions. That's what I do out of passion. Just to give back to the community. Also Google developer experts in AI. I take care of Google developer groups, Bangalore, and Google developer groups, Cloud Community Bangalore. So GDG and GDG Cloud Bangalore. How many of you have heard of GDG and GDG Cloud Bangalore? Oh, awesome. Good. Okay. So I'm one of the organizers for both the communities. But yes, community programs, DevRel has been kind of my entire life journey. Spent more than a decade in this journey. So yeah, that's what you'll find on my website as well. So what I'm going to talk today is about how do you containerize intelligence. So how many of you have heard of Neo4j? Quick show of hands. Wow, amazing. Have you worked on Neo4j? How many of you have worked on Neo4j? One. You've heard of Neo4j. When you say heard of Neo4j, is it the word Neo4j or see? Okay. Okay. So how many of you have worked on Neo4j or know the Neo4j fundamentals? Basically, a quick show of hands. So I'll not cover in depth about the next few parts, but just want to skip through. Any quick show of hands? No one who knows the fundamentals of Neo4j? Okay, couple of you. Fair enough. That's okay. Cool. So okay, this is a shameless plug. More facts, more giveaways. So we run this monthly contest every month across all the activities that we do in Asia Pacific. So if you want to be part of this giveaway contest, just scan this QR code. You'll get tons of resources as well. And trust me, no marketing communication. I'll pause here for 15 seconds if you want to just take a snap of it. I'll of course going to be share this in the last slide as well. But yes, still some phones out. All right, good. Moving on. So, who was worked on Neo4j, was not worked on Neo4j. So, what I'm going to start off is with a nice use case. It's a real world use case, explaining you about Neo4j and more importantly about graph databases as a concept. Have you heard of graph databases? Has anyone heard of graph databases? Other than Neo4j? Quick show of hands. Okay, good enough. Well, Neo4j is a graph database. We created this graph database as a category, and we lead in this category as well. But what I'm talking about here is this interesting use case about Panama papers. I'm assuming that you might have heard of Panama papers, Paradise papers, Pandora papers. All of them were worked by one single organization, which is ICIJ, International Consortium of Investigative Journalists. Now, these journalists were thinking about how do we kind of identify crimes, politics, everything connecting with each other. There's some dots that are connecting with each other, but there's the big shady system of transactions that were happening, cash transaction, non-cash transactions, everything put together. But how do we come up with a conclusion to say that yes, these people are connected, these people are not connected with this entire network, or these people are connected in an indirect way, and some or the other are actually responsible for the main crime. So that's what this Panama papers tried and identified. So how they started out, they got hold of this 2.6 GB of hard drive of 11.5 million documents. Now, these were not just the bank statements. These were emails, these were other scanned documents. Of course, bank statements were there. But how do you make sense out of this information? It was a humongous task to make sense out of this 11.5 million document, 2.6 GB of a hard drive, right? Yes, agree with me? Awesome. So what they started off with, they took one document and started analyzing the document. Okay, there's a person in that particular document, there's a mention of a person who has an account, and that account is with a bank in, let's say, United States. Now, that person lives at a particular address. At the same address, there's another person B. And then this person is an officer of a company. Now, this company is registered with the bank in Bahamas. Now, there's a lot of transaction that's going across these two banks or these two bank accounts, basically. But nowhere these people are directly being involved, right? Yes? So that's just one part of the entire bigger picture if you look at it. So they started piecing it together, combining things like a jigsaw puzzle in itself. And eventually got hold of a big, nice graphical representation of the entire data, 11.5 million documents and 2.60 hard drive. So that's a big picture I'm talking about where you're not sure where your actual information lies. That's one of the examples of a graph database. You can go to infinite depth. You're not sure of the relationship that really exists in your data. This is how the connections are really existing. That's what a graph database can help you uncover. Okay. I'll cover next few slides in a quick time because I don't want to spend more time on graph databases alone, but want to focus more on how do you containerize the intelligence. We are talking about GenAI these days, and how do you combine everything together, GenAI, Docker, and combining it with Neo4j as well. Okay, so how it starts with a small circle that you see over here. That's the Neo4j fundamentals that I'm covering up in next 2 minutes. So it starts with a circle, which is basically called as node. So you might have heard of graph theory. Right? Graph theory, you have circles, lines joining. That's essentially what it is. So you have these nodes. These are your entities. These are your things in your graph. Now these can be represented by one or more labels. Like for example, if I'm talking about a movie database, I have movies as one of the labels. I might have other labels as well. Like I can have a separate node for actors. I can have a separate node for directors. I can have a separate node for, let's say, writers and producers, so on and so forth. Now, this node also holds data in the form of key value pairs, as title as Toy Story, release as 1995. Now, as I said, I have another node, actor, Now the connection or the relationship between the two nodes, an actor and a movie node would be, let's say, acted in. But the producer and a movie would be, let's say, produced, right? Or a director and a direct movie would be directed, kind of a relationship. So a relationship has a type, and then it also has a direction. Now, what you see these kind of the boxes or the circles, these are kind of the real, not I don't say the real world, but kind of more like a graphical representation or a graph way of doing a Neo4j schema. Now, these acted in this relationship type also hold data in the form of key value pairs, which we call as properties. For example, Tom Hanks acted in Toy Story, but the role was of this actor was Woody. Right? Now, similar to way you query a relation database or a NoSQL database, there's a way to query a graph database as well. We use something called a Cypher. It's a proprietary language by Neo4j, but it's also an open source language, an open source activity. So ISO, the International Standard Organization, spent in a good amount of time to build a standard language for all the graph databases called GraphQL language. So Cypher is already compliant with GraphQL language. So your learning curve would be easy, your migration curve would be easy if you move from Cypher to GQL. Okay. So Cypher works, as I said, like these are the graphical representation, and that's how it actually transforms as well. So your circles becomes your round brackets, your relationship type, like the boxes becomes your square brackets, your labels are represented within these round parentheses, and then your relationship type is added in your square parentheses, and then you put the direction. The direction is very critical. The direction goes from person to movie and not the other way around. Yes, so you map the direction as well, and then PR and M are your optional variables. It will help you query your graph easier. Now, how you query, how it works in real world scenario, how do you query for a real world example? So you can write to Neo4j, not just read from it, but you can also write to it. You can create these kind of patterns within the database, but you can also find out what is maybe the shortest path, or how there are clusters within the data itself. So this is just one example. So you can there are multiple ways of writing it to Neo4j also. So again, I'm not going to go to the depth of it. I'll show you a slide towards the end to help you get yourself familiar with Neo4j. So you can write to Neo4j. You can of course read from Neo4j. Now, if you look at this query from reading from Neo4j, it is very, very similar to what you have been studying or doing it in your SQL world, right? So imagine something similar to like your from or your joins. Your where is where, and then return is something similar to your select query. I think I might have slide, but I might have skipped those where I'm talking about how it, like why relational versus graphs. I'll skip that part, but in general, this is how the mapping would look like. Your rows, how it maps to your nodes in a graph. Joins are your relationships, your table names are your labels, and columns are your property. It's a very good mapping, interesting mapping, and then you can easily migrate from a SQL to a graph world as well. Okay. What's next? Okay, this is like a overall holistic view of how Neo4j is structured or how it looks like. So of course, there's a native graph database, but there's data science and analytics on top of it that you can do. There's a lot of development tools and frameworks. Most of them are open source, so you can use whatever you want. For visualization, we have a nice tooling called Bloom. You can use that. This GraphQL language support, as I said, and then ecosystem integration. So we are not just a standalone database, but we also integrate with your Apache Spark or Kafka connectors, or even with all the your hyperscalers like Google Cloud, Azure, any of those, even AWS anywhere. And then yes, of course, it runs anywhere. So we have a couple of options. You can run it on-prem, you can run it on cloud providers, or you can use our self-hosted version, our kind of like a SaaS version, a database as a service, as we call it, RDB. So you can use the RDB. Everything is available for you in a click of a button, which I'm going to show you in a while. So that's what Neo4j is in a nutshell. Let's move further. These are some popular graph use cases. Some companies that have been using. Of course, tons of them. Almost all the top Fortune 100 companies are using Neo4j right now. Okay, that's the interesting part now. So, how many of you are familiar with RAGs? I'm going to cover a little bit on the GenAI side of things as well. RAGs, yes. Anyone who can tell me about GraphRag by any chance? Anyone knows GraphRag? This is something special. I'll give out a goodie. Everyone loves goodies. That's why you are getting active. Yes, no. Anyone who can tell me about graph rack? What is graph rack?
Basically, the vector graph store the data.
Why?
Because the data like storing in the graph, it is easy to finding the data, comparing the vector.
Okay, then what else? Okay. It's there, it's partially correct, 50% correct. Anyone else who wants to give it a, I saw a hand over there, someone wanted to, yes. Okay. Okay, yours is also 50% correct, so if you combine the two together, that's the right answer about it. That's what graph rack is. Okay, I'll give it to you both. Okay, connect with me after this talk. What happened? Okay, so we know LLMs make things up, they hallucinate, yes, and that's where came the concept of vector RAG. You're all familiar with vector RAG? Yes? Okay. So you know that there are PDFs, it gets divided into text chunks, then there's a vector database, you convert it into vectors, store it as an embedding, store it over there. When a user asks a question, it finds the nearest vector and give it to you. Simple enough, good enough, yes, awesome, good job. No disregard to vector RAG. But when I'm asking multi-hop questions, I'm not sure where the answer really lies, or if I'm really hitting the right vector or not. When I'm asking a lot of context-rich questions as well, and of course I want a context-rich answer as well. That's where we have a feeling that vector RAG tends to fail. For example, if I have, let's say, a database where I'm putting in all my contracts across multiple organizations, thousands of organizations, and just putting it into a vector database, just dumping it over there, and then querying it. If I query, let's say, what are our contracts with Admin Corporation? No, there could be a possibility Admin Corporation is having a reference in maybe 100 documents, but the actual documents that I'm looking for maybe just 10, the actual signed document with Admin Corporation. So when it's trying to retrieve, it might even give me result from the rest 90 documents as well, right? That's where the vector RAG tries to fail. But there are other reasons as well where we feel that the similarity alone is not sufficient enough to give us a better result. What else? And of course, misses out on critical context. And then we know that vector similarity is not equal to relevance. I'm asking for something where I want to find some connection, some relationship, but it's not giving me the right answer to it. And the last, which is getting very, very popular these days, the reason why enterprises are looking forward to switching to graph RAG is the explainability. The entire black box nature of a vector RAG kind of discourages enterprises to find out where the answer lies and where the information lies and which sources did you refer to, which entities did you refer to. So that gets solved in a graph RAG. Now, as I said, there's no disregard to vector RAG, because in a graph RAG approach, we are actually combining vector RAG and then doing a graph traversal. So we identify the start node through a vector search, and then we start traversing the graph and find out more hidden relationship. So how it works, there's something called as a knowledge graph, and that's why I want to introduce the concept of knowledge graphs as well. Now, if you look at knowledge graphs is in a very, very laymanish term, this is what I kind of understood. It's a combination of multiple graphs. So you have real world situation. Now, real world situation like an enterprise in itself won't have a graph which is just one graph which is standalone. There could be multiple graphs which are connected to each other, but we don't know. Maybe a supplier information and product information are also connected. So you can have a separate graph for supplier, you can have a separate graph for product, you can have a separate graph for, let's say, distributor. But the three can also talk to each other, right, in one way or the other. Now, eventually, forming a big network of graphs, that's what I felt would be the right explanation for knowledge graphs. So here, there could be, you can say, probably two or three knowledge graphs that are coming together. One would be, let's say, my person data. There are two person, Lily and James. There's another graph could be around places and locations. There could be another graph around interests and activities. So combining the two graphs together, two or three graphs together, and you're eventually kind of identify. So if I'm querying something where I'm asking or want to make some recommendations of places which Lily should go for, because James has visited a place which is also having a painting made by Da Vinci. So I can easily give that recommendation to, let's say, Lily, for instance, right? So that's what knowledge graph looks like. Now, if you look at a vector RAG approach, or rather a RAG approach in itself, we are not getting away with vectors over here in a graph RAG. Our real world representation of a data would still exist. Now, knowledge graphs can be divided into two parts. You can have one which is like your lexical or a document graph. So as I said, you have your document existing out there. The document that the PDF or unstructured source essentially would be just one document. Now you're dividing that document into multiple chunks. Now these chunks are also connected with each other in a graphical way, and that's what we call it as a lexical or document graph. But then you also going to have a domain or entity graph, which is like a structured information, or maybe even the information which is fetched from these chunks. You can even identify nodes and entities and relationships from these chunks and form a graph out of it. Imagine if you just have unstructured data, no structured data, you can easily get the graphical representation out of the chunks and form a structured graph as well, which is essentially your entity or a domain graph, which is your graph representation of a real world or digital world that you're modeling. Now, these two graphs are not mutually exclusive. They're not disconnected. They're rather connected to each other. So your chunk also shows a mention of maybe one or two entities or more than that. And then of course the entities are connected with each other through relationships, right? So all in all, what you're doing is you're fixing your elements by adding a left brain to it, by giving them explicit knowledge through knowledge graph. Now, knowledge graphs or Neo4j doesn't act as a standalone product itself. You rather build your entire GenAI stack with all the open source offerings, and then you Dockerize it, put it into containers. And that's what I have as an example later on. So you combine everything, you build the entire GenAI stack and just Dockerize it, as simple as that. So you use generative AI models from any of these services, you host your own embedding models as well, do the orchestration through Llama Index, LangChain. These are just two examples out here for orchestration frameworks. We also have integrations with Haystack, Spring AI and stuff. Build your own applications. You're expert in Java, use Java. You're expert in Python, use Python. You want to use JS, you can use JS, anything. You want to build your own chatbots, you can Streamlit, Radio, anything, custom one. You can do that. Everything is possible within one single GenAI stack. Okay, so now the first most question that comes in, okay, I have an unstructured document, I have let's say, thousands of PDFs. I want to build a knowledge graph, but I don't know where to start from. How do I make it super easy for me, for my development team, to build a knowledge graph from my unstructured data? So we have built a tool for you. It is super easy. It's an open source tool. It is super easy to help you build a knowledge graph. All you have to do is just submit the document. That's it. And it extracts the entity. It of course builds a knowledge graph for the unstructured data like a lexical graph, but it also builds a domain or an entity graph. It finds out the named entities from your graph and from your chunks, and then start building the graph out of it. And then eventually you can converse. And then if you want, you can, once the data sets into Neo4j, you can also develop your own front ends and UIs out of it. Okay. So what I'm talking about is LLM Graph Builder tool. It's a very nice tool, very easy to use tool. There's some options I'll show you in a while. So it's hosted on this particular URL if you want to take a snap of it. It's a production ready tool as well. There's a nice documentation available. While it is hosted over there, we give you 3 LLM support right now, which is Gemini 1.5 Flash. We also provided GPT-4o, and then we also provided Riffbot. But you do not have to put in any of the tools. They made it free for you. Just connect your Neo4j instance, and that's it. No keys needed, and it does start generating a graph for you. Even from your PDFs, YouTube transcripts, data setting in AWS buckets, data setting in Google Cloud Storage buckets, anything is open. Even Wikipedia pages or your web pages as well. It creates your web pages and Wikipedia pages as well. I have a couple of Wikipedia examples. All right, so what's next?
Will this work on audio files?
No, not yet. So graph is not multi-modal. So you have to work with textual data. What you're going to do is convert, take an API, any API, random API, which is good. So just convert your audio to text and then store the text in the graphical format. That works, yes. But not directly as an audio. or you can do metadata filtering. So you can take the audio, use the metadata information, and put it in a graphical format. That also is an option. So you can have a combination of audio to text, then the metadata of the audio. So put everything together, and then you can build a graph out of it. Alright. So as I said, to containerize everything. How many of you work with Docker desktop? Wow, amazing. It's a brilliant tool that Docker folks have developed. An amazing one to make your life easier. I just had to use this two containers, Olama. One is Olama and LLM Graph Builder. Now, as I said, this particular tool, which is hosted on Prod right now, just gives you 3 LLM models. But what about the other LLMs? I want to use something, let's say, easy. I want to use Claude. I want to use, what else? Give me some examples. Do you see Claude, anything else? Olama 3, right? Any other models, you can use it just directly within this tool via these Docker containers easily. So if an LLM is hosted on Olama, it's super easy to just directly call an Olama container, the model name, and you're done. That's it. That's all you have to do. Very small work to be done. Okay, let's look at a quick demo of how the tool looks like and how it works. Okay. This is my tool. What I'm going to do is I'm going to start. Okay, I think I'll stop sharing and then I'll just share my entire screen. So my entire tool is hosted on GitHub. This is where the tool is. I'm just giving you steps in a very easy format. You can of course replicate and or read more on the README on the documentation on this library. So this is our LLM graph builder library. A simple git clone to this library is what I did. And then once the git clone is done, all I have to just create is a copy of this environment file. So there are two kind of sections or two kind of containers that we have created. So one is a front end separate and then back end separate, depending on how you want to use. You can even deploy your backend as a separate instance, front end as a separate. You can even create your own front ends if you want to. So that's the luxury that we have given you. So for backend and frontend, there's an example environment files. You just have to make a copy of it, create new environment files, put the APIs over there. For example, let me just show if I can. So for example, I've just changed some configurations for my Anthropic. I just gave an Anthropic model name and the API. I've also given in Llama. So I've just put in the Llama 3 from Llama directly and just hosted, just running the Llama directly on my laptop right now. Similarly, do it with front end, make some changes, which models you want to use, which models you do not want to use. You can just update it in this configuration file. Make those similar changes to your Docker Compose as well in your environment variables, and that's it. That's all you have to do. And then once you're done, you just have to do Docker Compose up. The first one you might have to build it again, but once you're done, you just have to do Docker Compose up. And it starts your front end and back end together. If your of course it's going to be cached because my instance was already loaded in advance. And later on, you will see your instance coming up. 1 second. Just 2 more seconds and it will just start my application. How many, while this is happening, how many of you are IPL experts, cricket experts? 1, okay. Anyone else? I have a task for you. Okay, this is started. Just 1 second. I'll tell you the task. So, as I said, you have a drag and drop of your documents. You can do web sources, you can do S3. In the dev environment, GCS is disabled. You can enable it as well, as per your wish. Now, what I've done is I've taken this IPL's Wikipedia page and converted into a graphical format. I'll show you that. So there's some junk as well, of course. So there is my document for IPL. And if I just double click on it, I'm not sure if it's clearly visible to everyone. So this IPL over here is the main Wikipedia page, the blue one, and then the rest pink ones are your chunks that have been created. I can just open up any of the chunks randomly, and then I can see how it's connected with the other chunks, and also so you can see that, for example, this chunk is what I opened up. It was also part of the other two chunks out here. And then I can see there's some entities that are being fetched, qualifiers, sunrise and Hyderabad, Romanians. Now, let's get back to the tool. Okay. Now we're going to use, let's say, Claude 3.5 Sonnet. And I'm going to ask which team won the first match of first IPL season. Now what? First match of the first IPL season. Okay. Let's see. Hopefully, it doesn't give up on me. It gives me the right answer. Wait, hold on. Let's try with another. So with the, let's say, Llama. Okay, now at the end of the day, it also relies on your LLM model, how efficient it is and how it is trying to fetch a response. But was the first match played on 18th April? Okay. KKR versus Gujarat Lions, according to KKR won the match. Okay. No, KKR didn't win the match. Oh, there was no Gujarat Lions? Okay. Wow. Okay.
Gujarat recently joined, like, it was between RCB and KKR. Brendan McCullum century, first year.
Yes, and that's why I don't rely on live demos. I got the right answer earlier. Wait, let's see. Let's see if the chunks were not. Let's try it again. First match or the last match. First, see this one. Who won the first IPL season? Rajasthan. Okay. My cricket is bad. Sorry. But one thing to note over here is just the unstructured information right now. If for instance, if I have my structured information where I know, okay, this match was played between these two teams, and I know that these were the winners and stuff, I can combine the two together so that I can get a better response for my chat. Okay.
The final match.
CSK. Okay. Hopefully, yes. Okay. The last one was. All right. Coming back. So this is one example. So what I did also is something similar with the other other Wikipedia pages. So for example, with James Bond, I can I can give it a try. Which actor acted in the first and last movie adaptation of James Bond? Who knows the first actor for James Bond? Any guesses? The last actor? Daniel Craig, yes. This chat is again, you can build your own chat interfaces also. So ultimately your data is in database in Neo4j, and then you can just build any of your own chat applications. Okay, so the first James Bond was Dr. No, which is correct, it was Sean Connery, and then the last one was Daniel Craig, and the last movie was Spectre. No, the last movie was 2021, in 2021, no time to die. Therefore, it's possible to see that they acted in the fourth of those in last movie. No, okay. Well, I mean, it's still kind of partially correct. If I have more information about the movie, I can connect with it over there. So let's move on from here and let's go to the next one, but it's almost done. So as I said, it's a React front end. You can build your own front end as well. It's there's a fast API in the back end. There's Docker Compose, which is orchestrating everything for us. Well, you can also use this graph. So instead of relying on, let's say, a front end like this that we have built, you want to have full control and functionality, you can use a GraphRag Python package as well. Just have to pip install Neo4j GraphRag, and you should be able to run whatever I showed you in a Python environment as well. Now, this is just a GenAI reference architecture, again, not just limited to these end user app or end user use cases. You can build your own use cases. So if you look at this architecture carefully, the data that's flowing in from your left to right, which is data sources are getting ingested into LLM graph builder. Now, LLM graph builder ultimately stores data in the form of a knowledge graph into Neo4j. Now, end user applications are retrieving data from Neo4j via a chat application. So that's how the architecture looks like. Next is some resources. I'm almost done. There's just a couple of resources I want to share with you to take back. This is a nice GitHub repo to see some more GraphRag examples. There's a web page, there's a documentation for our GenAI ecosystem. So the LLM graph builder, and there are more tools. So we're building one tool for agentic RAG as well. Everything's going to be live first on our neo4j.com/labs/GenAI ecosystem. So you can just keep this bookmark with you. I showed you the Neo4j Aura console. This is just one flavor to it. This one, once again, sorry. This one. So this is running as a database as a service. There's no deployment that I've done. There's no database running on my desktop. You can just go to a console.neo4j.io and start your own Aura instance. We provide one free instance for you to play around with, and then you can just upgrade yourself to professional or enterprise edition. And next and last is there's one more after this. So if you want to continue your graph journey, there's a lot of amazing courses, hands-on online courses that we launched for not just for Neo4j but also Neo4j plus GenAI. So, and we're launching content almost every 1 month or less than 1 month. You can take up 2 free certifications as well. Just go to graphacademy.neo4j.com, start playing around. These are amazing courses, very simple to use, simple to learn and experiment courses. So just get your hands dirty with graphacademy.neo4j.com. And what else? This is last. Yes. Again, just reiterating on the monthly contest. If you missed out on the earlier section, the first part. We are doing this giveaway. If you want to just take part in it, you can do that. Cool. That's it from my side. Thank you so much, and have a rest of a great day. Do we have time for questions by any chance? No? Feeling hungry? Yeah, I know. Same here.
You have any demo or just PPT?
They are getting paid.
Yeah. So this one I wanted to try, but not getting a time, so be honest. The first time you said na that structured and non-structured data it can query both. No, I haven't seen any other solution do that, right?
Yeah, no, there is no lesson.
So that's a big thing. To build two separate dashboard for.
Then you have to write different language for each database.
Exactly.
If you want to query language, then you have to query JSON. If you want
This is four. Definitely. Four.
Thank you. Any questions? Anything? Yeah. No, so we don't store any data. The every operation is happening is in memory management, right? Presto does not store any data. Okay.
Transactions towards the primary
So you don't have to change your DB, right? Or you don't have to move your data from anywhere to anywhere, right? You just need to introduce Presto to your servers or your cloud or ecosystem, right? And whatever query you will write, Presto will do the analysis for you, right? So you don't have to worry about the query optimization. You don't have to worry about the yeah.
So increase the number of transactions towards the production.
No. It will not increase the. As I mentioned, everything is happening on in. Right? It will not affect your original DB, right? Yeah. So most of the companies use for, as I mentioned, it is an open source. But if anyone wants to use for the enterprise level, so some of the organizations, so I'll give you an example, Adani Labs use the SaaS platform. So many of the companies build a multi-millionaire companies through Presto, right? Building a SaaS platform over that, right? So the Presto is free of cost, right? You must be heard about watsonx data, IBM watsonx data, right? So what the Presto is the core of that watsonx data, right? So it's free of cost. Presto is free of cost. Anyone who wants to use it, they can. Right? Okay, guys. Thank you so much. Thank you. You have been lovely all. Thank you.
Thank you, Saurabh. Moving forward with another talk, Cilium and eBPF, the ultimate duo for the Kubernetes network security by Rajni Kunde, software engineer at Global Logic. Over to you, Rajni.
Hi folks, I hope you all are all good cause we just had the lunch. So my topic is the role of eBPF in Kubernetes networking and security. So this seems to be a complicated topic, so let's see how easy I can explain the things. I'll try my best though. So before getting into the topic, so this is about me. I'm working as a DevOps engineer in Global Logic right now. Apart from that, I am a Docker captain as well. So recently I got selected as a Docker captain. Then I am a WTM ambassador. So that is basically Women Tech Makers ambassador. So where basically we try to bring more and more women in tech. And a public speaker, I'm a public speaker as well. I have given talks in many national level conferences, and recently I got a chance to attend AWS event as well, which happened in Las Vegas. So that was one of the best events that I attended. So this is the agenda that we have for this topic. What is the history of eBPF? We'll talk about what exactly is this tool. Then we have what the architecture looks like for eBPF. Then what is the role of eBPF when we are talking about networking and security. Then we have what are some challenges which we are facing right now and how we can tackle these challenges by making use of eBPF. then what are the best practices and some examples, use cases I'm having. And also I have a demonstration as well. So let's see if I'll be able to cover these all things in less time, then we can jump into the demonstration. Because demonstration is gonna take some time. So talking about Kubernetes security. So what do you guys know? Like what exactly we can talk about when we are talking about Kubernetes security? Anyone would like to tell anything they know? Like how we can maintain Kubernetes security? What are some things that we can apply and stuff? Anything if you know?
Authentication.
Okay. Authentication is just right.
What level?
What you said? Yes, APAC is there. Okay. Okay. Okay, so many things are there. But considering I can see some students are also here. So I would like to give a real life example. Okay. Like suppose if you are living in an apartment and there you are having multiple flats, like hundreds or 200s of flats are there in that flat. And many people are living, okay, so families are living in those flats. And there will be, like suppose if you are considering you are having an apartment, so of course you'll be having a security guard there and you'll be having numbers to your flats. So this is the ideal scenario. So if we are comparing the same thing with Kubernetes terminologies, so you can consider these flats as the pods, okay, and the families which are living in these flats can consider these as the services or the applications which are running in your pods. And when it comes to maintaining security, okay, so in real life case you are having a watchman or you'll be appointing some person to basically monitor who is coming and who is going out of the apartment. So this is how the ideal scenario is. So when we are talking about Kubernetes and considering the real life example that I gave, so consider you are not having flag numbers are not provided to your flags. So of course, all the people, suppose if there's some stranger who is planning to visit the apartment, so he'll get lost. Okay, so this is the flag number, but I can't see flag numbers only. So this is a trouble. And when we are comparing the same scenario with the pods that we are having in Kubernetes, okay, so the IP address that is provided to these pods is dynamic in nature. So that keeps changing as suppose because of any reasons your pod is failing or you are stopping the pod. So there are many things which can happen and you can expect some things like you are not able to have you are not having a static IP address for that. So this is one of the issue that you have that you are not able to find the right flag name. And then talking about security, like suppose if you have not configured CCTVs in your apartment, then you'll be having trouble. Like any random person can come to the apartment and they can do whatever the shit they want and they can go. So you won't be having any track of that. So this is one thing we have. And again, when we are talking about networking, so the family is from flat one, so if they are planning to visit some another flat, so if they are not having the number of the flat, so that is again gonna be trouble. So this is some scenario we have when we are talking about Kubernetes security. So how exactly this eBPF is gonna help with that? Okay, so this is the slide for what exactly is eBPF. So consider the example I gave for apartment. Okay, so eBPF here is gonna act as a super powered like backed by AI, a security system backed by AI, it will be acting as that too. Okay. So talking about the definition, we can say that eBPF is basically extended Berkeley packet filter. So this is a tool which is gonna let you run some like some programs which will be provided in a sandbox environment, and this you can run on the kernel without making any modification into the kernel's main program or the main code base that you have for the kernel, and there won't be any need to load the modules as well. So this is how eBPF is giving you that privilege that without making any modification into the kernel, you can run some programs. So talking about the history, so it was developed in early 90s basically to capture the network packets that you are receiving to your system. And it is that was provided flexibility again, like that was basically supporting assembly level programming languages. But when we are talking about like future, like how exactly eBPF is helping us with like bringing some more advanced features here. So eBPF is supporting high level programming languages like C. Like you can write these programs that you want to write for eBPF in C language, and this will be compiled to eBPF bytecode when you will be in the compilation process. And that is gonna give you more flexibility, okay? Like based on your use case, based on your requirement and whatever components or whatever different configurations that you want to give. So based on that, you can write this programs in Clang, and that you can compile, that will be getting compiled in the bytecode when you are using eBPF. So this is very flexible in nature when we are comparing with the traditional system that we had. So what is the overview of eBPF architecture? I'll show the architecture once. So this is how it looks like. We'll come back to this, of course, but let me just try explaining this different components we are having. So talking about eBPF program, so eBPF program is nothing but it's a piece of code that will be writing and that will be running in a sandbox environment in the kernel. Okay, and that will be following the JIT, that is just-in-time compiler approach. Then kernel virtual machine. So kernel virtual machine will basically provide a virtual machine in your kernel so that the program that you have written for your eBPF, so that will be running in that kernel, that virtual machine, sorry. So this is again the second component we have, that is KVM, that network interface. So when we are talking about eBPF, so eBPF can directly get into the network interface and it can manipulate the network, okay? So the network packets that we are receiving, so that eBPF can take and it can basically monitor, it can track and it can create logs for them and can again filter as well. So these are things eBPF can perform. So this is very flexible. And by basically giving these many things, we can say that we will be having a fine-grained control over the network traffic that you are receiving. Then talking about user space application, okay? So the user space application that you are having, so that will be communicating with the program that you have written, the eBPF program. And based on that, you can perform various operations like the networking thing and the security. So whatever things you want to implement, so you can do that using eBPF. So this is the architecture. Okay, so here the architecture is for two subsystems. One is for storage and one is for network. So if we start from the first component that we have is the process. So process is nothing but it will be a user space or it will be an application for you. Then this is the system call we are having and this is the Linux kernel we have. So basically to interact with the application and the Linux kernel we are having this syscall. So from the process we'll be receiving whatever read operations or write operations or whatever request that you are receiving. So that will be getting from process and that will be passing to the syscalls. And here again in syscalls you can add things like eBPF hooks as well, so that you can filter the request filter the request or the filter the inputs, we can say you can filter that as well, but you have to add eBPF hooks there. Then once we are done with syscall, we are getting into the Linux kernel. So if we are talking about storage subsystem, so here we are having things like file descriptor is there, where you'll be getting information about your file. Then we have VFS, virtual file system is there. Then we have block devices, so where you basically deal with the storage, block storage that you are configuring. So these many things are going to be there in your Linux kernel. And here also you can implement eBPF as well. And once you are done with Linux kernel, you can see here's the main subsystem that you're having, that is the storage. And similar is the architecture is going to be there for network subsystem. So the process is same, but instead of having these many components in your Linux kernel for storage, we are having different components like sockets, we have TCP/IP, we have network devices for the network subsystem. So this is the architecture we have. So what is the role of K8S networking and security? So what is eBPF's role in K8S networking and security? So in somewhat way, we discuss many things like how exactly it is playing a role in networking security. Okay. Talking about networking, so of course eBPF is gonna help us with filtration of the packets that we are receiving. Okay, and also we are having things like load balancing. We do have service discovery. So talking about this service discovery. Okay, so if you are having multiple pods running in your Kubernetes architecture and you are getting your request, okay, so based on the type of request you are getting, you have to make sure that the right request is going to the right pod. So this is how service discovery is going to work, and eBPF is going to help us with that. Then again we have load balancing as well. So also considering many pods are running, so we have to make sure that the load is getting balanced among all the available pods, because we can't keep like one pod is getting overloaded with the work and another is setting idle. So this can't be the ideal scenario. Then we are having security. So for security, we are having many things like network policies are there. Then we are having ACLs, we are having intrusion detection. Then again, we can make use of DDoS attacks are there. So these all things we can implement. Okay, so this is how like implementation of the security components and security approaches is very easy. And we are having observability as well. So again, when you are making use of eBPF, so when it comes to monitoring, like what exactly is the flow of traffic that you are receiving, and you want to basically filter the type of traffic you are getting. So keeping an eye on the flow of traffic, and again like getting into the system activity, we can say. So this process is very easy. Like very easily you can create these logs for monitoring. So what can be some of the best practices for eBPF solutions now? So first one we have is we can make use of some official existing libraries which are provided, like BCC is there, libBPF is there. So we are having different available libraries, so we can make use of these for like basically, if we are making use of official libraries provided, then of course we can be careful that okay, there won't be any bugs and errors. So that will be safe to use. Then we are having optimizing eBPF programs for efficiency and minimizing the performance impact. Okay. So again, you have to make sure that when you are writing a program, okay, so you need to make sure that you are writing it as complex as possible, because that is gonna help you with minimizing the performance impacts. Then we are having security controls and sandboxing mechanisms. So of course, we are having the sandbox mechanism. So you can make use of that to create the program, to write the program, and to run the program. Then again, testing the eBPF program. So before pushing your program into directly into the production, you can make sure you are running a trial and check, and you can test your program in the staging environment, and then you can push the same to prod. Keeping eBPF program updated. Okay, based on the version of the kernel, you can again make sure that you are keeping your eBPF programs up to date. So these are some of the best practices that we can follow. So this is one of the example that we have TCP dump. So TCP dump is basically a command line tool which is used for basically filtration of the traffic type we are receiving. Okay, so this tool again uses this eBPF methodology, or eBPF tool it uses basically to filter the packets using different matching parameters. Like parameters like we are having protocols, or we are having destination IP addresses. So considering these protocols ports, you can filter the different type of traffic that you are receiving and the different packets that you are receiving. So this is a really interesting analogy that will give you an idea how exactly eBPF is working. So this you can see, this is a static website and this is a dynamic website now. Okay, so in static you can see like it's not looking that attractive, and it is not like you can't make any changes into like it won't give any response if you are trying to make any changes here. Okay, but here in dynamic, when you are moving your cursors around, you'll see that it will respond something, but this is not the scenario with the static website. So in this analogy, how exactly eBPF is working? So eBPF is going to help us with dynamically make changes into your networking, okay, networking of your application. So just like how we are having this JavaScript, I don't know much about JavaScript, but JavaScript is going to give us this feature that you can make your websites dynamic in nature, right? So similarly, eBPF is going to help us with making our networking and security dynamic in nature. So consider if you are following the traditional approach, which was basically the kernel approach. So in that, if you are planning to make any changes into your networking, or you want to add some more security features, so for that, you have to directly go to the kernel's main code base, and then you have to check the code base, update that. So this process is really complex. Considering that if you are making use of eBPF, so that using that it will be very easy, like making any changes, because you just have to write the program for your eBPF, and you can run that in the sandbox environment. So this is very flexible in nature if we are comparing the same with the traditional approach. So this is the inspector gadget tool. So this is a tool which is created by Amazon. So this is again gonna work similar to eBPF only. Basically, it is used to like filtration, networking packet filtration purposes, and when it comes to monitoring. So for these all kinds, we are making use of this inspector gadget tool. So the demonstration which I have, so for that I'll be using this inspector gadget tool. Okay, let me just. Okay, so this is the demonstration I have. Let me, basically I'm just installing some dependencies here. Just checking some existing pods. Okay, installation. Okay, Creo is getting installed here. Okay, so here you can see gadget is getting deployed. So this is a plugin that we use. Okay, so seeing the list of pods available. So once we are done with installation of this gadget plugin, so we just check the pods for that. Okay, now we are, let me just forward this. Okay, so here basically what we are doing, we are creating two namespaces and we are basically creating different deployments as well, like based on the namespaces that we are creating. So in these namespaces, we are creating different deployments. So this is these are those commands. Getting a list of pods. Okay, here you can see the two namespaces which I had created and the pods which got created for that. Okay, so this command is basically what it is doing. So we are making use of this gadget tool here, gadget plugin here to basically create a log for what exactly is the networking policy that is being followed right now, the default one. So we'll be creating a log for that and we'll be storing here in a networking.log file. Okay, so using these commands, now the two namespaces which I had, so I'm basically trying to create, I'm deliberately trying to create a traffic from the first namespace to the second namespace. So this is that traffic is getting created and that will be stored in the same file. Okay, you can see this is the traffic which I had started from first namespace to another one. Okay, this is the log for that which got created. So now what is this command doing here? So based on the logs that we got now, which were stored in that networking.log file. So based on those logs, now we are creating a networking policy. Okay, so that networking policy is getting created here. So this networking policy will be basically having like least privileges that will be applied. Okay, so this is the policy that we got created, and now you can make use of this policy. You can apply this policy, and you can expect that like things like least privilege will be provided. So this is how we can make use of this. I have a slide, so there you'll get good idea. So this is how it is making a change. Okay, so considering the initial observation, we saw that we had two namespaces, Kerala and DevOps days, okay, and all the traffic you can see that was allowed earlier. But when we started implementation of that gadget tool, okay, so how this is restricting the traffic, the default one got blocked, and the DevOps days this namespace got blocked, and this queue system traffic that is also got blocked. But this is the allowed traffic based on the networking policy that got created. So based on that, this will be the only traffic that will be allowed, because this traffic I had created by myself. So based on that, it created the namespaces. Sorry, it created the networking policy, and that we applied. So this is how it is going to help us with maintaining security with the networking of Kubernetes. So these are some of the tools which are making use of eBPF. We are having Cilium, we have Falco, we have that is Hubble, that is Bumblebee. Again, apart from this, many like big tech giants in market like Netflix, I have heard they are also using eBPF. So that was the session from my side, guys. So if you are having any questions, or if you want to connect with me regarding anything like DevOps, cloud, and this particular topic, you can scan this QR code. You can reach out to me. Thank you. Thanks for the session.
Thank you, Leslie, for the talk. So guys, still I can see somebody is sleeping at back. It's okay, guys. Yeah, moving forward with the next talk. Accelerating CI pipelines, rapid Kubernetes testing with the V cluster, delivered by Ritik Roy, platform advocate at Loft Labs. Over to you, Ritik.
So, hi everyone. So we have some problems with the screen sharing. So we can see the slides, we can see the demo on the UI, but I am not sure about the terminal. But let's hope we can figure it out as we go. So anyways, hi everyone. Let me just slideshow. Yeah, step one is here. So hi everyone, I'm Ritik, and this is my talk on accelerating CI pipelines with help of something called vCluster. You might have remember this from the first keynote. So a bit about me. I'm this guy Ritik, and I go by Ritik here on socials, and I'm a platform advocate at Loft Labs. Apart from that, I'm a CSM ambassador, I'm a Google scholar, and I've done a couple of certifications and all those things. If you want to connect with me, you can always search Ritik here and you will find me somewhere. So I have a small quiz for you all. So if you can go to slido.com, slido.com, and just enter this number, or if you can scan this QR code, it will be awesome. So the first question is, what do you do? Are you a SRE? Are you a student? Are you a DevOps engineer? Software engineer? Test engineer? A lot of software engineers over here. More DevOps engineer, full stack developer, consultants, pre-sale. So as you see, we have someone is sleeping. I understand, right? It's a long event. I'm also a bit of sleepy, but you need to do things for the community and be here. So yeah, students, someone is unemployed, and we need to change that. Storage engineer. So yeah, a lot of people, 55 people, 56 people in the room. So I have a second question for you. Okay, some people are more typing. Christy. So what's the relationship between Kubernetes and you? So are you a total beginner, or are you a comfortable user, or are you expert? You can write controllers, operators, and all those things. So how is the relationship with Kubernetes for you all? As you see, most of them are total beginners, and some are comfortable user. So it's a very good event to be there because the talks are on a variety of ranges. The next question I have you is why do you think Kubernetes is popular? Like, what's the reason? Is it because they do good events? Is it because they have a strong community? Why do you think Kubernetes is popular? Community, what? Market value, open source, yes, open source. Um, because of Ritik, um, not really, but I'm just being the part. Providing high salary jobs, yeah, good pay. So yeah, it revolves around two, three things. The open source component, the component of that you can scale it infinitely, and then because we get paid well in this ecosystem as well, right? But the next question I have for you uh, is saving a cost for your infra something you care about? Like, do you care if you are saving more cost for your company, or you don't care about that? Yes, sometimes, not really. Yeah, like yeah. Like yes, is a lot of people are yes, so they care. But the next question I have for you is, why do you care about that? Because you like optimization or you like pay raises because you are saving costs and you can show your management. So what is that? Or do you like both of them? Both? Okay. Less people like pay raises. I want the second one to go up, but yeah, it's going up. You can change your answers by the way. Okay, fine. So anyways, what we got to here was like Kubernetes is popular, Kubernetes pays well, and Kubernetes is everywhere. So now coming back is a bit more theoretical stuff before we go to the demo. So whenever we talk about environments in org, there can be many of them. But we want to break it down into more simpler part because we have some beginner users as well. So one can be a developer environment, one can be a testing environment, and one can be a production environment. Developer environments are more close to the developer, where they build things. Testing is more close to your production. Ideally, it should be closer to your production, where it is a reflection of your production environment and where you can run integration tests and all those tests so that whenever you deploy things, it doesn't break, it is working. And production environment is where you serve the users. So when and coming back to Kubernetes as a de facto standard right now, wherever you are going, you are hearing about Kubernetes. The reason is Kubernetes is a large scale distributed system. Whenever you talk about Kubernetes, you find infinite capacity to load. Like for example, a lot of your teams can come together and they can have different nodes in different geolocations and different users which are having a same weight up to operate. So it doesn't goes in a way like if you are using a different provider, different cloud provider, it is breaking things. It is a cloud native way. And going back to the same concept, your testing environment should be closer to your prod environment. So whenever you talk about Kubernetes testing, there are three things. The first is you have your own cluster, and that cluster can be divided by in basis of namespaces between your teams, between your testing environments. But there are some problems which we will go on in some time. But this is a general traditional setup in any org. So your testing cases are run through your specific namespaces. But the problem is whenever you are doing something more than that, like for example, if you are testing operators, which are cluster level objects. So how do you do that? You have to go and create new clusters as you go, which might not be very efficient because anyone who has done cluster creation in cloud providers or locally as well, it takes time. You can't wait for 20-30 minutes just for a cluster to come up so that you can go and test things. That is not viable in that manner. And whenever we talk about traditional testing challenges, it is again in 4 different categories. First is inconsistent API server behavior. So you might have rate limit, for example, if you are testing secret creation in a high load, like if you are creating 10-20,000 secrets because you are testing a specific functionality, your API server may be loaded. So the problem with that is your cluster might be down, so you can't do the test again nicely. Then resource constraints and performance bottlenecks. Sharing a cluster between different teams can cause that, and noisy neighbor and all those problems are very common. Next is networking difference between your different environments. So whenever there is that problem, you can have noise collision, DNS problems, and all those. So with that, your testing environments might be a problematic. And last is delayed provisioning. So if you are going and creating a EKS cluster every time you want an environment, it takes time, and it takes time in two ways. It takes time for your CI action because they are waiting for the cluster to be there so you can test. And it also takes time for your cluster creation, pulling images, going through the pipeline. So everything as combined is taking time, money, because actions cost money. So coming back to one very common slide, which we have seen before. So as companies grow, they feel to optimize their flow, like if they are building operators and all those, they feel creating a cluster for every PR, creating a cluster for every developer, creating a cluster for every environment is the most optimal way. Because you get unified admin access to those where you can run and create and test different operators as well. But I think that causes issues in a way that you can have hanging clusters as well as unnecessary clusters for different teams. So if you open your logbook, you will see there are so many unnecessary clusters. So talking about the CI bottleneck. So there are three bottlenecks mostly. So first is time consuming. As we discussed, it takes time for your cluster to come up or your actions to spin up. The second is resource intensive. So right sizing, there is a lag between both of those. So right sizing your specific cluster with your specific PR is also very challenging because you don't know how much capacity you will need. You can define resource quotas and all those things, but again, it's not that optimal. Last is action time, as we discussed again. So action time, yeah, same. So cluster warm up, cluster like installing all those operators, all those CRDs, installing all those tools you require, like your ingress controller, site manager, all those for your optimal testing cycle. Those take time. So your developers might be waiting in the loop for all those provisioning, all those creation, and all those issuance. So what can be our specific solution which we can have? So we can learn something from containers. So containers are way faster. Right now, whenever we use actions and all those things, everything underlying is going through containers. Solutions like code spaces, DevPod, all are there because they provision your development environment in the container because it's fast, it's isolated. It's very fast in comparison to EKS or something like that. But again, there are other benefits like suppose you have a specific CRD for your specific clusters, you can sync it. You don't need to go and install all your operators, all your controllers again. You can just sync between your different clusters. And currently, there's generally two ways to deploy Kubernetes and deliver them between your teams. One is separate cluster, as we discussed initially. So the problem with that is there is a long wait time. Tools need to be duplicated within different cluster, which takes time. Ops has a nightmare to manage all those hanging clusters as well as clusters that are not being used. And again, you need to pay for all the control planes of different clusters. So you have all those challenges on this front. But on the other side, where teams operate on a namespace basis, the problems are a different kind of problems. Yeah. So first problem is lacking enough permissions as well as lacking clarity between different CRDs. Then infra owners have create bottlenecks as well. So you can't do a lot of admin things which you want to for your specific team or specific test. Then there's problems like noisy level. For example, all your teams are creating secrets in a very high frequency. But the problem is when all of your teams are doing that, there is a very high load on API server and your API server might crash, bringing back all of your clusters. And then there's weak isolation as well between namespaces because namespace skipping is very easy. So here I want to introduce vCluster again. So if you have seen the first keynote, it was about vCluster. So we are a popular open source project right now, and we are having used by companies like Atlant, Covix, and a lot of banks, manufacturers of chip. So what we generally do is we'll go into architecture in a bit, but a lot of virtual clusters are being created, and we are very popular on GitHub as well. So whenever we talk about virtual cluster, I will reiterate the first keynote is that you get a way to create a cluster inside of your cluster. And the good part about that cluster is it's a certified Kubernetes distribution. So you can run anything you want inside of the cluster and it will work like your normal cluster. Apart from that, what you need is a host cluster. So your specific team can have a host cluster. And for each of your CI pipelines, each of your CD pipelines, you can configure the virtual Kubernetes using manifest. So your teams can have a virtual cluster which replicates the condition of your production cluster, and you can run anything over there. So it's fast and lightweight because you don't need to go and provision a lot of things. Yeah, it's faster than this. So the time taking to sync. So it's faster than that. And next is, yeah, as we were saying, we can wait. Yeah, it's fully Kubernetes compatible. It's just replicates your normal cluster, so you can use it for any of the use cases. And losses, you can isolate and sync specific resources. So for example, you want to sync something from your host cluster for your specific team with specific use case, you can do that. And the last important thing is, whenever you create a virtual machine, a virtual container, you use the same piece of underlying hardware and you don't need to pay extra for hypervisor or something. It's same over here. You bring your host cluster, the cluster which you are paying already for, and for different CI pipelines, you just create virtual clusters on top of that. So if we go a bit into the benefits you get eventually, so there are 5 areas whenever we talk about multi-tenancy. First is isolation, second is access for tenants, like how easy is for your teams to access the virtual cluster or your normal cluster. Third is cost, resource sharing between different teams, and overhead. So if you see virtual clusters come in a central piece where you get the best of both the worlds without compromising a lot. For isolation, you can have CRE isolation and all those things. For access for tenants, you can share the true config of your virtual cluster easily between your teams. For cost, you don't need to pay for any of the extra control plane cost or extra cost related to running your cert manager ingress controller again and again for each of your PR or resource sharing as well. Lastly, there is no overhead because you just define a manifest, and whenever your pipelines are configured and pipelines are triggered, you will have a simple cluster as easy. You don't need to make a lot of API calls or anything. So if you want to just see the architecture again, so whenever if you see there in the top there is a virtual cluster. So for each of your TI pipelines, you create a virtual cluster automatically as you define on your manifest. And with all those deployment, everything is synced back, including your networking layer. And if you want, you can sync back all everything from your host cluster to your virtual cluster. So you have powerful, which reflects your normal host cluster environments. So you can use it for any of your use cases. So we will see a simple demo right now over there. So for demo, I need to configure this screen sharing again. So let's hope that works. Is it sharing new screen or something? No, nothing. So I can't show the CLI because I can't share my entire screen. I don't know why, but I will just show you the GitHub UI, and a lot of things will happen in the background, but I will explain you. So for example, we will do a simple PR. So this is a simple repository, and we have configured GitHub Actions in a way that your vCluster can use it. So this is the simple GitHub manifest. So if you go for every pull request which is happening in the main branch, we create a virtual cluster, and the steps are very simple. You install the vCluster CLI on line number 11, and then on line number 14, we log into the virtual cluster platform. So where your clusters can be provisioned, and with the access key and everything which is stored in secrets. For every PR on line number 20, with the GitHub event pull request number, we create a virtual cluster. And those virtual cluster, you can define it way like with ingress and cert manager and all those things. So what we will do is we will just go and change this into something, and then create a new branch. Create a PR over here. So now, once the PR has started, so it will start couple of checks over here. So if we go to Actions tab, you can see the checks have started. So if you see, the steps are very simple. It logged in using the vCluster CLI, and now it is creating virtual clusters called PR15. So if you see, the pull request was also 15 number, so it is creating the same virtual cluster over here. And if I can share this tab, this is the UI for the virtual cluster platform. Like you see, we are creating a virtual cluster over here right now with all the configuration and everything. So it will take time. And once this is done, it will, if you have some tests configured and everything, share this tab. So if you have tests configured on everything, it will take some time to be created, and it will run all the tests defined on your YAML. So, but in this example, we don't have those defined. And then it will delete the cluster because we have defined the deletion in the YAML. So if we go to the workflow file, so once everything is done, it will auto clean up your cluster. So there is no wastage of your resources, and your host cluster can crawl down depending upon your auto scaling rules. So this is like, if we had the CLI, we can have shown it in a more detailed way. But the simple fundamental is you can define how your host cluster is there. And whenever there is a new PR, it will create a virtual cluster quickly which reflects your normal host, as well as all the parameters, all the controllers, all the operators which you want, that is reflected of your host cluster and your production environment. So let's see what's the status. So the virtual cluster is running, and we go to this tab. Some time to initialize, but we will skip that part and just go on the other one use case. So this was a very simple use case, but if you want to go on a more complicated use case, so I have this simple diagram. So suppose you have two users and each of them create a PR, and then what you can do is you can add a label, and every PR which has a label, it can create a virtual cluster, and you can build and everything over there. And then whenever your host cluster has all those ingress and ingress controllers over there, so your virtual cluster can consume that and create an endpoint for that. And if you want to just delete the cluster, you can just remove the labels and that will trigger one more action. So by which you can either manually delete your virtual clusters or you can delete automatically as well. So if you want to focus on some other use cases where you can use virtual cluster. So for example, a lot of MLOps things are happening right now. And suppose you want a couple of your inference tests and all those to be done. So you can configure, like whenever you create a normal virtual cluster or a normal cluster even, you need to define the GPU and it takes time to provision. So with that, you can provision specific GPU virtual clusters, which will save your team some time. Then if you want CD and all those things, you can use Argo CD and Flux for creating deployments on those virtual clusters as well. Lastly, if you want CRD syncing, as we discussed again, where you are syncing your specific pipelines and your specific production environments to a real environment, which is reflecting your test because it takes time for you to install all those things, like all the operators and controllers. So if you just want a replica of your production environment, which is reflecting on your version, that can be done as well. And if I want to conclude this talk, so at the end of the day, whenever you use something like a new technology like virtual cluster, you're not just improving the cost, but you're improving your developer experience. Most of us only care about user experience in our org, but developers are one of the most important and paid resources we have. So if you are saving time and saving them energy as well, it is a cost saving on its own. Next is you can reduce your build times. So when you reduce your build times, you are reducing the cost. You're improving your test cycles because it is taking lesser time for you to test some new change, as well as you are saving money on control plane because you're not creating new EKS control plane. Whenever your team wants to test a new operator or a controller, you are saving action minutes. And lastly, you are saving developer time. So we have a very active Slack, which you can join right now using this QR. So if you have any questions related to this talk, I'm here only. But suppose you are testing this thing once you are back home during this weekend, and if you are stuck somewhere, so you can always join the Slack and ask us questions. Our team is very active over there. This is me. I'm Ritik here on socials. So you can just connect with me if you have any questions. If you are trying this out and need any help, we'd love to help you there. And thank you.
So guys, have a round of applause for Ritik. So we are moving forward with the next talk, leveraging Istio to connect legacy VM workloads to Kubernetes by Syed Imran, DevOps engineer at Container. Over to you, sir.
Stickers if someone wants to do it. Is it there? Yeah, already there.
Guys, there are the stickers
For vCluster.
vCluster, DevPod, and other community stickers. You can grab it from that desk.
I'll just move this. Right. Please select the speakers a bit faster so I can get started and I will let you go as well. Hope everyone's awake till now. Yeah, that's fine.
Okay, guys, yeah, this is Saurabh here. I know I'm the last thing standing, between you and the end of the day. So let's make it as painless as possible for both of us, right? Cool. So my topic is leveraging Istio to connect VM workloads to Kubernetes, right? So before getting started, a bit about me. I'm Saurabh, working as DevOps engineer at Convin AI. And very recently, I got certified as a Kubernetes that this week itself. And I did saw a guy who is wearing that jacket. I'm really waiting for mine. Apart from that, I hold some other certifications from Google Cloud and Amazon as well. Yeah, that's pretty much about me. Moving forward with the agenda, we'll see why when we need to run workloads on a VM, right? In the first place, why do we need that? Well, next, we'll have a brief intro about the service mesh, and then we'll talk about Istio and the sidecar pattern, which is relevant to the topic of the day. And we'll see about gateways in Istio, workload and workload entry. Then I have a sample application that I'll be using to demonstrate on how we can use this VM to connect the external workload with the Kubernetes, right? I will tell about the whereabouts of the application and how I'm going to use it, right? And then at the end of this talk, I'll have a small video which will demo the entire purpose of this talk. Moving forward, right? Why workloads on the VM in the first place? So there can be multiple reasons to that and possibilities as well. But I find these four pretty relevant ones, as per my opinion. Legacy applications, yes. There are some legacy applications out running still because of some dependency loggings with the traditional infrastructure and the application architecture. And second reason being security and compliance, right? That is something I have personally been through, that the clients, right, which they come to us with the requirement that they want to host their application in their own VM, and they have limited access to that VM. So that is something is the reason that we still run workloads on a VM. Third being the gadget migration process, and I believe most pretty common use case that the entire monolith gets breakdowns into microservice architecture, and eventually you are migrating the application to the Kubernetes cluster, right? And fourth, and being the last, handling stateful applications, right? I believe almost everyone who is running Kubernetes would agree to this, that running stateful applications on a Kubernetes is way more headache than running it on a VM. The operation, that you want to perform as the backup and restore, this is pretty much easier when you run things on a VM as compared to Kubernetes, right? So these four being the pretty much reasons why we are still running workloads on a VM. And moving forward, about talking about service mesh. So I have skipped a part of introduction to Kubernetes because throughout the day everyone was just giving a pretty good introduction to Kubernetes. Thanks to the esteemed speakers that they did a part of my work that I don't need to introduce Kubernetes now. And yeah, so talking about service mesh. So already one of the speakers mentioned about Cilium as a service mesh, right? So what exactly it is? It is a dedicated infrastructure layer that does the heavy lifting for you for the service to service communication. It offers multiple features, four of them being the security, observability, traffic management, and resilience. Right, security by we can implement mutual TLS between the service to service communication. That is something Istio does. We can make use of Istio to have it. Observability, right, and built-in tracing matrices and log collection. Instead of having that particular part in our application, we can make Istio do the same instead of letting Istio do the heavy lifting part. Traffic management, advanced level traffic management is much more easier when we use Istio as compared to Kubernetes. Although we can do definitely perform such advanced traffic management, but it's way more easier when we use an Istio, right? And for the resilience, by introducing circuit breakers and all those are pretty much easier when we use Istio, right? Yeah. So talking about Istio, it extends Kubernetes to establish programmable application aware network. Right? What is programmable by means of programmable is to basically we can very tiny details we can configure when we use Istio to manage the traffic in Kubernetes, right? So Istio has two mode of operations: the ambient mode and the sidecar mode, right? So what happens in the sidecar mode is Istio injects a sidecar container with the main workload to work along with the main workload and act as a helper container. And
this is how Istio operates and does the heavy lifting that I was talking about, right? Traffic management and all the logs, metrics, and collection, all those stuff. In the diagram, as we can see, there is a proxy container running alongside the services, which happens to be the one injected by the Istio. It's just the heavy lifting part. Yeah, that's about. So for this particular purpose, right, to inject connect external VM to a Kubernetes cluster, only the sidecar pattern is something that will be applicable. In ambient mode, it's not yet supported. Moving forward, yeah. So gateways in Istio. So when we introduce Istio to the environment, right, there are multiple components that are responsible for the full-fledged working of Istio. But we won't focus on all of them. Rather, only two to four things that we focus on. First comes the ingress gateway and the east-west gateway, right? In ingress gateway, as like the ingress, Nginx ingress gateways, but completely same. It's the entry point for the external traffic that comes to the cluster. Pretty similar to what Nginx ingress controller does. And there is another gateway, this east-west gateway, right? So that is something that we'll be using along with the Istio to make this external VM connect to the cluster. And that is the entry point for the VM to connect with the cluster. Just reading out the definition here. Ingress gateway is in Istio manages external traffic entering the mesh, acting as a control entry point. And coming to east-west gateway, it enables communication between service across multiple clusters or between Kubernetes and VM workload. That is what we are going to see right now. Okay, in the diagram as well, you can see the user is able to using this ingress gateway, the Istio ingress gateway is able to communicate with the workloads that are running in the Kubernetes cluster. Whereas the external VM is using this east-west gateway to connect, act as if it was part of the cluster itself. Things will get much clearer when we go to demo. Okay, so please bear with me. Right. So there are some custom resources that are used by Istio to support this use case of connecting any VM or any workload wherever it is running. Right. So one of them being the workload group. So it is like a something that gives a template to the workload that is supposed to be connected. The way we have deployment, right? In deployment, we mentioned the template of the pod that we want to run. Right. The same way in the workload group, we define the template of the workload that is going to be connected from the VM to the cluster. Right. You can see the sample workload group, how the Kubernetes resource looks like. It's very simple. It defines the metadata labels that are supposed to be used in that workload and a service account associated with it. Right. So workload group is something that we need to deploy manually from our side, like the way we deploy Megha deployment, right? Use it to apply and all those things. The workload group is something that we need to create manually. And when the VM tries to connect to the cluster, it comes as a workload entry. So using this workload group, we define the template and workload entry. That is the next custom resource from the Kubernetes, from Istio, that comes as a workload entry from VM, when the VM connects with the cluster, right? So there's a sample workload entry as well, you can see. And then the owner reference, it is referring the workload group that is being used as a entry with the VM, right? And yeah, that's pretty much about workload group and entry. Yeah, so I have used a sample application for this use case, demonstrate this complete use case. So in the initial setup of this application, there are primarily 5 components, I would say: data service, UI service, image service, and there is something is not visible is the logo of Minio and object storage and MongoDB, right? So data service basically fetches the metadata of the application. It's a okay about the application. It's a I would say animal album. It just fetches the data of some animals, random animals, and so the image of it. Okay, so there is one endpoint that fetches the data. That's the data service. That's metadata of the like what exactly is the animal. If it has any captions to that image, and there is one other endpoint that's image service. That is basically the endpoint where the image is being fetched, right? And UI service, of course, where everything is shown up. Cool. So there are primarily 5 components, as I was just mentioning again. There is a MongoDB database as well, where the metadata of the all the application is being stored. In Minio, all the images are stored, and the respective services fetches the respective data. That in for MongoDB is the metadata, and for Minio is the image itself, right? So what I'm going to do is I'm going to move this data service from the Kubernetes to the external VM acting as the workload itself. Okay, and we'll eventually scale down this data service, and we'll see that things are still working. Okay. Yeah, that's the overview, that UI service, data service, image service, Mongo, and Megha, right? Good. If anyone wants to just have a look of this hosted here. So it's very pretty simple application, it's nothing big deal. I mean, so the reason I'm showing this is to just demonstrate that we can connect external workloads without doing any further application level changes with the code changes, that we are able to onboard any workload from running in external VM with the Kubernetes cluster seamlessly. Right, running to the demo. So, in this video, I'll be launching a Kubernetes cluster on Google Cloud, right? So once the cluster is up and running, we'll install Istio using Istio command line. Then we'll install the application, right? Cluster is up and running, you can see that. Using the gcloud command, we'll get the kubeconfig data, and we'll once the kubeconfig install Istio command line in our local. So that is one of the way of installing Istio into a cluster. There are other ways as well, using maybe Helm, that is much more easier. And we're configuring the Istio command line. Then we install the Istio using Istio command. And we also need to specifically enable this east-west gateway, because that is not a default configuration. It only installs ingress gateway when as a part of default installation, just installs the ingress gateway. You can see the operator is up HTOD, and we have all the gateways are also up and running. Right, Istio is up and running. You can see all those components of Istio are present in Istio system namespace. I'm just waiting for the public IP to show up for both the gateways, ingress gateway and the east-west gateway. Right. I'll just upload this video and all the slides. So no worries about that. Now we are gonna deploy the application and the sample application that I mentioned about, right? Right. You see the pods are spawning up. The entire application is up and running now in Kubernetes cluster. So eventually what I'll do is we'll move this data service running in here to the workload. I'll get launching a VM to simulate external workload to be set up. So once this VM is running up, what we'll do is we'll run this data service as a normal Python use the Python command to run that service in the VM, and eventually we'll scale down. So the VM is up and running. We'll connect with the VM. Okay. So for setting up this external workload, we need to generate some artifacts that we can do using the HTTP command. So these artifacts are basically the details of the cluster, from which gateway and what IP address the VM is supposed to connect to the cluster. Right? It's an east-west gateway that it needs to connect with. Right? So these five files, right? The cluster env, host, Istio token, mesh, and root serve. So these are the 5 important files that gets generated using Istio command. And we need to move these files to the VM and install a Istio sidecar package on that VM to be able to use these files and connect with the Kubernetes cluster. Right? User. So we have already moved those files using G-Cloud command. And what we'll do is we'll just place the generated files in respective destination and install the Istio package. is not up yet. So what we'll do, okay. We need to create the workload group first, right? So because workload entry is dependent on workload group, so that needs to be created first because, right, that's how it works. Workload group is up. Now we'll start the issue service of the VM. As soon as VM connects with the cluster, we'll see that a workload entry resource, workload entry resource in the animal album namespace because the entire all the application is the same. Till now it's not up there, so we'll keep a watch on that. The moment we makes the connection, we made the connection, so we can see there is a workload entry in the animal album namespace. Right. So what we'll do is we'll just scale down this data service in the Kubernetes and we'll just run that exact data service as a that workload on the VM itself. You can see this is the external VM where I'll be running the data service. This is a small file like to run the data service, and once it is up and running, so we now hit the application. Right, that's the sample application that QR has showed. Right. You can see the traffic is already coming in. What we'll do, we'll just delete that, scale down that deployment completely. We'll wait for it per minute. Right, so it's just the external VM that will be serving the data service component of the application. You can see still things are up and running. Right, that's how it's pretty much easy to connect any external VM to a Kubernetes cluster. Right. Yeah, that's pretty much with the thing. Yeah, so now what is happening currently is, if you see, this is the current setup, and there is no more data service call running here. This data service running in the external VM, which is communicating through east-west gateway, and also the data service, as mentioned, right, it fetches from MongoDB. So there is both ingress plus egress traffic happening through this east-west gateway itself. When the data is being fetched, so that service call happens to data service, right? Then it needs to fetch from MongoDB. Again, inbound traffic is happening to MongoDB. So that's how seamless is to help us to connect any external VM workload to the Kubernetes cluster. So this is, I believe, much more helpful when we have stateful workloads, the fourth reason that I mentioned, right? And we run databases on a VM. That is something in our company we have been doing it. So we have the stateful applications running in VMs, and we have enabled Istio to connect those VMs to the Kubernetes cluster that we have running. Right. So yeah, that's pretty much about the topic. And here's my link tree. I can reach out. You can definitely connect on LinkedIn. I'll be uploading all these slides and the video as well. Yeah. Does anyone have anything to say or ask, please?
How is this different from ingress configuration? We could do it through an ingress pathway, right? Like exposing it to an external traffic and getting it sent.
Ingress is responsible for the incoming traffic from the user side. Right? But if you saw, the external GMP didn't do any external configuration, which is something. It is similar to how to say. It is something. It is acting as if it is running inside the cluster itself. We didn't do any extra configuration at all. We just installed Istio, remove the generated files. Those are basically details of where exactly the cluster is running. That's it, right? So there is no extra overhead that we need to perform. But if we need to do ingress, it has to. I think we need to resolve static and all those other stuff that needs to be done. Right? If we have, but also one more thing is that using this this gateway setup, this load balance also happens. So if it acts as a pod itself, there's no difference. It's just abstract away that there is a VM totally in the space. It is something similar to the VM acts as if it was a pod running in the cluster. It just simplifies that part. Yeah. That's it then. Thank you very much.
So guys, now we come up on. Don't leave, guys. It's time for quiz. So yeah. So again, I think now we don't have constraint. because we have upgraded it, and I think the audience is also not much now, so we can easily play everyone along. And again, there is a leaderboard. Top five will get yeah. Top five will get the like top three people will get code cloud subscription and stacks from this street. And just you have to provide your email to us. And rest two people will get the Kubernetes Bible book from Packet.
Shall I share whole screen?
Yeah.
Enter screen, no?
Here's the quiz. Share the yeah, guys. Yeah, requesting you to scan this QR. And after that, after the quiz, and like whenever you are, whenever guys you are leaving, then please keep your badge to the reception. And after this quiz, we will have a group picture. Then you can guys proceed. So we'll wait for 5 minutes. So all set.
Hey guys, can you unmute yourself? Otherwise, people joining in Zoom can't hear. Hey Kunal, Anand, can you unmute yourself?